question. I don't know whether Rafe is listening. That is, did you ever meet Rafe, perhaps in Vienna at a conference?
I don't think so.
Do you see Rafe? Are you Rafe met with Popper. He was like Popper's Australian representative, so to say. But I was wondering whether you two connected in Vienna. I think when you said Vienna, there was a reference to one of the conferences in honor of Karl Popper.
2000, I forget.
In 2002.
In 2002, 100 yeah, exactly.
You
may I ask,
remember? Yeah.
did you meet or do you remember meeting Carl Milford, perhaps?
No.
Okay. Because
Can I say something about Radnitsky?
Radnitsky, yes. I think
Radnitsky became seriously depressed to the point of being suicidal.
Oh, I didn't realize that. That explains a lot.
Now I found this out from a German called Wolfgang Kasper.
He was from, where was Radnitsky living? I've forgotten. Was it Trier? No, that's in Württemberg. I've forgotten. I didn't realize that. Thank you.
Now, Wolfgang Kasper was an associate of Hayek and Radnitsky, knew them well. And when Radnitsky became depressed, he persuaded him to write a memoir to give him purpose in life, which he did. But regrettably, it's in German. It was never translated. But I think that probably tells you all you need to know about him.
That's interesting. I did not know that, and explains a few things. His mood was very odd and very strange. And I don't
know how long that lasted. I don't know how much it changed when he recovered. But we had a slight correspondence going by snail mail. But then he suddenly died, and that we never met, and we never developed a friendship much.
I suppose I met him during his depressed time because he really exhibited sort of strange, not behavior, but attitude, I suppose. Very sad, very sad.
Well, you probably know his background. He was a German pilot, and he absconded to Sweden, married a Swedish girl, and they set up in Germany. But I think he was somewhat at a loss when she died, as though I get the sense that he suffered a sense of isolation, probably because of perhaps that background of sort of fleeing the country. That would have been a bad thing in many people's eyes.
I honestly didn't know that.
Mm-hmm. So
very little is known about him, actually.
Little is known. Did you ever meet Klaus Pehler?
No.
Okay, because he was a student of Radnitsky, and he's still around, but he couldn't. He was going to drop by, but perhaps later. Now, did you ever meet Ray Percival?
No.
No.
I know the name, but I never met him.
Okay, because at some point in the 90s, people started organizing conferences dedicated to Karl Popper's philosophy. So what happened? Where did you go after Karl Popper, if I may?
I went back into teaching because I was supposed to take up a post in Australia, where I regret I didn't, with a Professor Flint in Perth, and I then took up teaching and then went into business, essentially.
Okay. And so then, how did you decide to come back in the? Was Jeremy the one who reached out to you, or how did this happen, or did you reach out to Jeremy?
I understand the question. I understand the question, but philosophy never leaves you. it's an itch you want to scratch, so to speak. And I didn't read. It sounds later at the age of 13. Didn't understand a word. But somehow, with my surrogate mother, who was a primary school teacher and a communist, which I was, a bit like Carl in actual fact, for a couple of weeks until I saw the violence associated with socialism, communism. And throughout my life, I'm very sensitive to the word philosophy as such. That is, I think it is simply a way of seeing the world, maybe a definition. And all of my life, I've always had an interest in, let us call it philosophy, or is quantum mechanics philosophy? I do not know. Is natural science philosophy? I do not know. But things that I just find things interesting, as does Carl. And I can see him just sitting at a very small table by the piano, sitting there, oblivious to the world, writing a paper. And it's a kind of thing that guides your life, I suppose. They're silly terms. It's absolutely silly terms. Sorry.
So I thought perhaps I heard that Jeremy is writing a book on Bill Bartley. Or how did you discover Jeremy? Did by accident the conferences, his Popper seminars? How did you?
I think it was last year when he had this online conference, and I joined that, and that's how I knew of. Obviously, I knew of Jeremy as well as David, but more or less last year, I believe. And you were one of the speakers, if memory serves me.
So I'm curious, is it like purely like by accident, or that you just kind of woke up and you say, or did some email come across your, did you contact Jeremy? Yeah.
I wrote him one email.
Okay. Yeah. All right. Okay.
Ask me a philosophical question.
So we are getting ready for the next session, I guess. So for anyone who just joined, this was Ivan Slade. He was an assistant to Karl Popper in the early 80s, if I'm correctly. And he actually made a huge difference in that he had employed the lovely Mrs. Mew, who then ended up being Popper's personal assistant for the remainder of his life, and who helped establish the charitable trust, and who gave, my understanding, a lot of the stuff of Karl Popper to the University of Klagenfurt, where that is now making it available to us all. So thank you very much, Ivan, and I hope to continue, I plan to continue talking with you through email. Anyone who wants to know, get in touch with Ivan, you can just send an email to our Karl Popper, and we'll get you in touch with him. And now I'll give it to Elise. I'll give the word to Elise, who shall introduce Sadia, who will talk about philosophy of science and philosophy and the connection between the two. And I think it's a much neglected connection that we desperately need to talk about more today. Elise? Yeah.
Margarita, just before you go, can you please make sure that Sadia has permission to share her screen?
Okay. Sadia, then we let me double check this. Yeah, thank you.
I'll try to share actually what I have. Yeah, right now it's disabled.
All right, so then bear with me for a minute.
So while you're doing that, University of Kentucky. Sadia has been participating in these meet and greets from the beginning. In the first one, she organized a session with Bruce Nielsen and David Deutsch. And last year, she coordinated a session with Dennis and Ray Noble. So she's going to be giving a presentation followed by a roundtable discussion.
All right, thank you very much, Elise. Let me first share. I have a presentation. I thought that would be the best idea to kind of get across some of the things. This is the last slide, but this begins with, let me see if I can. All right, here we go. All right. So just to give you a little bit of a background where this comes from, it's from, it started off as my personal interest in foundations of physics. You know, when I was in academia, I really wanted to always really understand things in a deeper manner, which eventually kind of led to me leaving academia as well. And in my own time, because I didn't want to be constrained by these papers that had to be written and constant publishing pressures. I really just enjoy physics so much that I wanted to do it my way. And I don't know if it'll ever get anywhere, but this is fun for me, and I do this now on my own. So the talk, first of all, a quick thing about it says open universe and indeterminism. Let me just absolutely be clear. Here, I'm not making a case for magic or mysticism or anything. It's not about those type of things that you should buy this book called The Secret, where anything you believe in your mind is going to suddenly start happening. It's none of that. You know, it's a pretty conservative view that I'm going to present here with an utmost respect to science and what it has achieved so far, which is amazing and awesome. So a little bit about the points that I mean to discuss here in my, here are, first of all, the meaning of this determinism, the meaning of determinism in scientific context, then the metaphysical meaning of determinism. Are these two supported by actual science, and how science, you know, what science says, because, you know, I'm going to start by what in science determinism means. Then I'm going to go into the concept of what I mean by closed versus open universe. What can we know is basically the question we're going to address there. And it's much more than just what can we know. And another thing I really want to raise, because this is one thing that I've kind of come to realization, is how mathematical Platonism, with its structuralist flavor, you know, a big focus on representation, structure, is pretty much abstracting reality to the point of literally creating, or almost to a declaration that I've been seeing in a lot of scientists. And they are kind of, even if they don't declare it, I see that intuition that the world is sort of like a ghost. Interestingly, that has actually made a lot of these people interested in Eastern mysticism, whereby the world, the Tao, the unknowable, and the you know, the world starts from nothing, you know, and those type of ideas are kind of coming back, and they point to something happening here, which I hope to talk a little bit about. And finally, I will present a case for open universe and what that actually means for science as well as our day-to-day life. So it should have implications for all of that. And I think I might reserve the question answers maybe at the end, just so that the flow remains and I don't lose my chain of thought, and then you know, we can discuss this. So, so I'm going to start with the idea of scientific determinism. When scientific determinism comes to mind, I'm not trying to give a definition. I just want to give you a basic idea of what we really mean when we say scientific determinism. In physics, and a lot of this is going to be focused on physics. So it's basically, it's based around the ideas of symmetries and transformation. Things can transform into other things. Processes, when they evolve, can be imagined like as if they are transformations. Not all transformations are continuous, but, you know, for most part, the ones that are interesting to us, where we can meaningfully talk about conservation laws, are the ones where there are some sort of continuous symmetries. So these continuous symmetries are very much related to conservation laws. Conservation laws are really important in science because it means that there is something we can do if we see a system and we can come up with some sort of a quantity that is conserved, then we can make predictions, and you know, we realize that in the system something unexpected isn't going to happen that is not captured by our conservation law. Laws are often expressed, so there are the conservation laws, and then there are the dynamics, but they're kind of closely related. So these so-called laws of physics are expressed as differential equations, and we solve these equations to make predictions. And a lot of times solving the equation is associated with computational science. So there's a lot of computational science involved in physics. And then another thing that is quite often associated with scientific determinism is causal closure versus causality. As a matter of fact, I would say that the proper association really should be causality and not causal closure. I should have put that thing. The last two are the ones where I would say they are naive scientific determinism. The causal closure and reductionism, I'm going to place them in the naive causal closure, because you'll hear physicists talk about this, but this really isn't, I think, part of science. This is more in the category of metaphysics. But causality and reduction are part of science. That's what I want to clarify. I think this distinction is not made, I haven't seen that being at least made out there. All right, things associated with, a little bit more about the things associated with scientific determinism. A lot of times, and I'm not saying all science is reducible to that, but quite often in science, we deal with isolated systems when we apply these conservation laws, when we're talking about symmetries. We talk about isolated systems. An isolated system is basically something whereby it doesn't exchange any matter or energy with the outside environment. Now, obviously, in thermodynamics, we can study systems which are open, but a lot of this determinism is very much tied to conservation laws and to isolated systems. But let me also point out, no system is ever truly isolated. Isolated systems are an idealization. They don't really exist in nature. We are the ones who define an isolated system by focusing on certain relevant variables that appear in the framework of our theory, which we capture them. We capture those through our equations, and there's so much other stuff that we don't find relevant to the problem we're trying to solve, so we just ignore it. But that doesn't mean that there is such a thing as an isolated system in the universe. It's just an idealization. It is something we work with, and we define it based on the problems we're trying to solve. So these conservation laws, or these inherent symmetries of dynamical equations, allow us to make predictions in science, and then we go and test our predictions. And despite of some people having kind of undermined the importance, and I quite hear a lot of people coming, and I'm not saying that what Popper said or anything, but I see that a lot of people who come from a Popperian angle somehow do tend to undermine the role of predictions. But if you're a scientist, it means a lot when your theory makes a prediction and it basically gets tested and you find that thing. Like, for example, not too long ago, we found, we got the evidence for the existence of gravitational waves. We also got the evidence of Higgs field, the existence of Higgs field. Those meant a lot to physicists. So there is no, like, if you're a real scientist, those things matter a lot. Your science is all around that. So it's really important. So a little bit about scientific determinism, a little bit more. So the determinism is framed in the context of problem. I've already talked about it. I just want to quickly go and make sure I didn't skip anything here. Yeah, a little bit on the symmetry laws. So for example, just to give you an idea about what I mean by symmetries and how they're related to conservation. So this one thing that everybody almost knows about is the law of conservation of energy. The proper way to really understand that in terms of symmetry. So it means that if you have some sort of an isolated system, it has a symmetry that whether you perform your experiment a little bit to the right versus to the left in your lab, then you're assuming that you're not going to find any difference in your experimental results. All right. Now, obviously, that's an idealization. But what we're really assuming is that the space itself intrinsically doesn't have any property that that differentiates between left versus right. So this is tied to, so the law of conservation of energy, law of conservation of momentum is tied to the symmetry in space. And then you can think of the same as the law of conservation of energy is tied to the translations in time. In other words, what it really means is that the physics doesn't really differentiate our dynamical equations where the symmetry is inherent, doesn't really differentiate between a forward-backward arrow of time. Now, I'm not talking about the second law of thermodynamics. That's a different thing, and I might talk about that later. But what I mean is that your basic equations, if you have a differential equation, what you define as initial condition versus final condition, it doesn't matter. The equation doesn't care which one is the past, which is the future. So you can run it either ways. And so kind of like we're just like we can move a system left or right in space and very related to saying that there is a symmetry there that you won't find any difference in the in any of your predictions is tied to the law of conservation of momentum. Similarly, now imagine spatializing time in your mind's eye. You're thinking you do the same in time, and that's what's connected to law of conservation of energy. Now, obviously, in reality, we know that the time you can't do that type of stuff to systems in time. The time is, time is different. We live in the present and we have information of the past. So this is all very much, talked about it in that, in an abstract way, not to be taken too literally here. But the problem is people are taking this sort of stuff literally, and that's what I really want to talk about today. So physical equations, that, as I said, physical equations do not differentiate between past and future. Dynamical equations are considered past, future, deterministic, run the picture back or forward. If you have an isolated system, you should be able to make prediction of what happened earlier or what's going to happen in the future. As long as you have an isolated system and your equation captures the dynamics of that system and you have the relevant symmetries and so forth. But I want to also highlight, which is not so well known in public, but some physicists have talked about this, that even the textbooks don't seem to mention it that clearly that much. And we keep teaching anywhere from high school to undergrad, that anything that, the conservation of energy and momentum and all these things are kind of like have some sort of a universality, and not just universality as that you may not find any difference whether you do this on Mars or planet, but also sort of like as if they have some sort of a domain independence, that they are some sort of transcendental type laws. But to kind of give you an idea, in general relativity, space and time themselves become dynamical. They can warp and so forth. They're not like the Newtonian time, like some background. The space is not like a background. And the time, there isn't some master clock on which the universe ticks. So in general relativity, time kind of becomes dynamical. Your clocks can tick at different rates, whether you're in a stronger gravitational field versus weaker and so forth. So in general relativity, the conservation of energy is only meaningfully defined locally. In other words, in very tightly constrained conditions, as long as your gravitational field is uniform, you can kind of locally define law of conservation of energy, but there is no global notion of conservation of energy. As a matter of, so in other words, there's no saying that the reality as a whole, there's some sort of a law, transcendental law that applies to the universe as a whole. But as far as we can see, if the universe looks reasonably flat, and we can define, so as long as the gravity doesn't change that much, we can meaningfully talk about that, and we can do local level experiments, and we can locally have a meaningful law of conservation of energy, but not globally. Okay. In quantum mechanics, the law of conservation of energy becomes sort of like an average type of a law that we associate an average energy with quantum state, and specific measurements can fluctuate around this average. I'm just going to make sure that I haven't suddenly disappeared somewhere. Let me just take a look. Everything good? Everybody can hear me? If somebody could give me a thumbs up, I'll make sure. All right.
We hear you.
All right. Thank you. Thanks, John. All right. But let me maybe pause for a second. So far, is there any question? I don't want to get too sidetracked, but if there's anything, because I don't want to keep yapping until everybody just gets, forgets if there's any point, because I really want to get to the last point.
Quick question.
For that, build up.
Quick question. Just to clarify, you said causal closure and causal closure and reductivism are metaphysical, and that causality and reduction are legitimately part of physics. Didn't quite get what you meant by that.
I'm about to get to that. I'm going to discuss what I mean by all.
It comes at the end again. Okay.
Yeah, I mean, I'm about to actually say something about causality.
Okay, great.
All right. Any other questions or anything? Okay, I'll move forward. All right, so now let me just make sure. Okay, so a little bit about causality and determinism. Causality is basically, it's a basic assumption behind determinism. And that holds for science as well as day-to-day life. So whenever we observe an event, you know, something happens, we think in terms of causality. You know, that's kind of a very basic thing to our thinking in general. And then, you know, we tend to believe that when we see something happen, that it has a cause, that things don't happen without, like things just don't happen without any type of thing causing it. There has to be something. So the basic idea behind causality, I mean, you can think of that as kind of determinism, like that if something happens, even if we don't have an explanation, there is at least in principle some explanation to why it happened. It is not magic. It just didn't pop out of nowhere. So that would be kind of the basic idea of causality, not causal closure. Causality, as in what causes what, is an added explanatory layer to dynamics and not part of it. So what I'm saying here is that the equations in themselves don't have causality built into them. It's an added explanatory layer that we add. As a matter of fact, there are certain places where there are certain solutions of equation, like in electrodynamics. I don't want to go into too much detail there about that, but we will even throw out some of the solutions that we'll say are not physical. And then even in special relativity, we kind of, you know, we have these light cones, and we basically constrain, like when we look at events, that which events can affect which events, but the special relativity in itself doesn't dictate that. It's an added explanatory layer to it. So causality is an add-on and is an added explanatory layer. It's not part of our equations. Our equations don't really, in our equation, like if you look at our equation, there isn't really a causal arrow there. They're pretty much causally reciprocal, if I want to put it this way, kind of like the Newton's third law. To every action, there's an equal and opposite reaction, action, reaction. You know, there's, I mean, we don't even say what's the action, what's the reaction in a physics equation. It's all just two things interact and that's it. So, but when we say that this event caused that event, that's an added layer. But the thing is that overall physicists do hold this belief that there are causes, and without a cause to an event, one could not create predictive science, basically. I mean, there are causes to events. As scientists, we hope that all events have causes, so we can do science and understand the world by modeling it. Because if stuff happened in the world which had no causes, then what would a scientist do about that, right? Except for just take it as it is and study, but we wouldn't be able to make a connection of what happened to anything that happened earlier. So not to say, I'm not saying whether causality is part of everything there. I'm not making any metaphysical claims. All I'm just saying is what I mean by causality here, and why it is so, like why it ties in deeply with the determinism. So to have a scientific or rationalist attitude really boils down to take the challenge to make sense of the world. We take that attitude that the world can be made sense of. This requires a commitment, and notice that I'm using the word belief. It requires a commitment to sort of a belief, or you could say that you have some sort of faith in this idea that the universe is open to rational investigation. Because if magical things started happening, then that would be the end of science. Unless if magic happened and the other things didn't. But let's just focus on what science is about. All right, we're not talking about magic here.
With your permission,
Mm-hmm.
I disagree.
All right. Do you have maybe a quick point on?
Science,
do you disagree that there is?
Science does not rule out magic. I can never forget friends of mine who said two things about science. One is that science does not deal with the question, is there a God or not? And secondly, that science says that there is no such thing as a God. And they didn't hear themselves.
How about, I'll tell you what, this is an interesting topic and we could go over it in the end. Would it be possible for you to hold on to that thought so we don't get
Yes,
too
we-
sidetracked?
Yes, I can. Yeah, no problem.
Disagreements are always good, you know, and especially the interesting ones. So I think this would be a good one.
Thank you.
All right. On top of that, if I add the word causal closure, now we've done something else. I think now we've kind of gone into a little more, quite a bit more into metaphysical. And this is just simple thing taken from Wikipedia, where the causal closure in a stronger form means that no physical event has a cause outside the physical domain. Now, the question is, what do we mean by physical? And that is another thing I really want to kind of talk about, because people keep using the word, oh, is consciousness physical or non-physical? You know, what do we mean physical? And I think from how much I've been thinking about this, I think I'm going to give you at least my take on what I feel like what physical means, and why saying that. And I have a lot of objections to physicalism, and it's not because I think there is something non-physical. It's just that physicalism itself, there is something else going on. They frame it in a certain way. They mean something which the world isn't. So what is the world? There are lots of open questions in there, but I'm going to get to that later on. But for now, in the stronger form, the causal closure means that no physical event has a cause outside the physical domain. Weaker form, every physical event has a physical cause. But the causal closure means that if no physical event has a cause outside the physical domain, I think there's another sense in which the causal closure is also invoked. And that I'm going to talk about. This ties into another idea called holism. So when you think that the universe is a closed system, like the universe is some sort of a whole, then causal closure takes another form. And I don't think anybody can defend causal closure for that type of universe, or even for any isolated system, we can't defend it, because there's always an outside world, right? There always can be causes from outside. It's just that the way we're solving the problem, those causes may not be relevant to us, but at least we keep believing that even if our problems expanded to some other aspect of that system, then there might be causes that address that, right? So that would mean causal closure, at least in a sense, for that closed system. But I would much rather just call it causality and not causal closure, because there's always something outside. And it's just that we frame problems, and we hope that as we come up with new problems dealing with different aspects of the world, our isolated systems become kind of, they evolve, and then we will figure out what those causes are too. So, okay, so causal closure in that sense, not the Wikipedia sense, but in that sense, take a whole new shape in cosmology, where people start talking about universe as a whole. Okay, so some distinctions need to be made here. So this is what this is kind of one of my theses that I want us to, I think we should make this distinction, that even some of the people who have gone against reductionism somehow start falling back into reductionism and contradicting themselves. Some of the Nobel laureates have done that. I've seen that in their paper. They first talk about that, they bash reductionism, how that's wrong, but then suddenly that, you know, we're doing reductionism. I'm like, what are you saying? Like, did you just contradict yourself? I think it's because they don't make this distinction. The distinction is between reductionism versus reduction. Then there's another distinction, holism versus wholeness. These are my own words, and you will know what I mean by them. So don't try to match them with some definition out there. Try to understand what I'm trying to say. Causal closure versus causality. Again, try to understand what I'm saying versus some definitions out there. Science is so the biggest thing I want to talk about here is that science is based in reductionism as well as wholeness, but not reductionism and holism, which are baseless claims. And by reduction and wholeness, we mean something which is not metaphysical, which should not be metaphysical. But scientists confuse the two. And they confuse the two, and they start making statements about reductionism and holism. And then they also, not knowing not being aware of what they're doing philosophically, they also claim that what they're doing is science. And they declare, look, what we're doing. Reductionism is science. No, it's not. And the same physicists, unfortunately, also hate metaphysics. So they remain in this cloud of ignorance and keep making metaphysical claims while propagating baseless metaphysics. And this is such a shame. This is so bad. This is just total like ignorance, I would say. All right, so a little bit about reduction. Science definitely works with reduction, right? When we look at a system, we try to understand what we call laws. You know, we're basically studying regularities in the system. We're using regularities in the system to make predictions, and those regularities pertain to some sort of ontology. And I'm not talking, when I say ontology, I don't mean something fundamental here. What all I'm saying is that there are parts to the system, and we want to see that if we can capture certain regularities of those parts and make predictions, and where we can do experiments and see if we captured some sort of regularities in that system. And that has proven to be extremely useful, particularly in physics. It's been awesome. The sort of predictions, like our predictive science has taken us to places which we never thought existed, like in the sense of ideas and phases of matter and so forth. And we've even found those, like the very computer that I'm working on wouldn't be possible if we didn't have quantum physics. So science has been pretty awesome at what it does. So in the case of reduction, let me see what I was going to say. So basically, we have equations and we have models that deal with different domains of phenomena. This is one of the things that I think scientists quite often overlook, that all science is basically, all these so-called laws of nature are actually domain dependent. And yet somehow scientists keep talking about laws of nature as if there are some transcendental laws that live in some platonic realm from which they control the world, but there is no such thing. Maybe in the time of Newton, you could have defended that idea. That's the type of idea which also very much comes from a very religious type of perspective, and has made its way. It's just that we have replaced God with the idea of the law of physics, a mathematical law. And then we also seek this perfect law, the theory of everything, that once we find, it's going to be the thing that governs everything, and all the other little local level laws will meld together, come together in this, in this big kind of a law. And there are physicists who still keep believing in this theory of everything, whereas everything that physics has shown us, which starting roughly, I would say 1800s till now, has actually gone over and over against and against, and there's more and more evidence building up. And at this point, if anybody believes in the theory of everything, then I honestly don't know. It's kind of like people who just want to believe in whatever, spaghetti monster or something, and they just want to hold on to that. I don't know. Okay, so there are equations and models that deal with different domains of phenomena, whereby the equations are often solved by using approximations. So whenever we hardly ever really, if ever, derive anything from first principles. What we do is that we have these equations. You have equations in quantum field theory and quantum mechanics. Rarely do we have any exact solutions to equations. Most of the time, especially when it comes to when the number of particles go up, when the systems become more like complex in terms of how many particles there are, when we start adding their interactions, we have to resort to all sorts of approximation techniques. In quantum field theory, we end up running into infinities, which make no sense, and then we come up with the methods to tame our infinities, so we can, and a lot of times those taming of infinities require us to pay attention to experiments, and then we tame those infinities, and then we can do something useful with our equations. We also make all sorts of simplifying assumptions, and in some cases, they're pretty good approximations. But physics is basically, a lot of times ends up being studying systems, aspects of the world which are simpler. The world is not simple, and quite often physicists will declare that, look, the world is really simple. No, the world is not simple. We create simplifications, and we focus on the aspects that are that can be studied in simplified way. But even the rest of the physics, where we have to do all these tricks, that kind of came as a surprise. And even you'll hear Richard Feynman had said he was very much disappointed by this whole thing that he had to do. Like I mean, he wasn't the one who came up with it, but the idea of taming infinities, renormalization, you know, that kind of broke the Platonic dream of a lot of people. But yet they still held to this idea of Platonic mathematics somehow, in the laws being kind of like a manifestation of that Platonic mathematics that control the world or something like that. So finding exact solutions hardly ever happens. It does, but most of physics, that's not the case. The connection between physics and math is not straightforward. There is no isomorphic. I want to repeat this one and pause for a second. There is no isomorphic relation between physics and math. There is no isomorphic relation between physics and math. Sorry, Platonists, if you keep saying this, you don't know physics. So I'm going to pause for a second. I feel like maybe somebody had a question.
Can you give a definition of causality?
Pardon me, say that again. Sorry, you were cutting off.
You give a definition of causality.
I'm not going to worry about giving definitions of causality. I think that what I described should be good enough to say that, look, if something happens, something caused it. It didn't just pop out of nowhere. It was not a creation out of nothingness, right? That's what I mean. That would be something that is not caused by anything. If something just popped into existence out of nowhere, then we would say that doesn't have a cause.
But it sounds like no. It sounds like something.
I'm sorry, you're breaking up.
So it just sounds like, from what you said, it sounds like something quite.
I'm so sorry. Like, you're really breaking up. I hardly captured what you said.
Yeah, it's like every second word is done.
Yeah, I couldn't hear you. Let me get the next question, and then maybe later on. Yeah, Brandon, you had your question. Brandon, you had a question.
Hi, sorry, I was trying to unmute the.
Oh, sorry.
No worries. I think what you're saying is very fascinating, but I want to ask you about your no isomorphic connection between math and physics. Do you think that is like an absolute idea, or do you think there are parts of our universe or of physics that can have an isomorphic connection? For instance, Newton's laws.
Well, here's the thing, right? I could present to you something that might tickle my fancy, how I want the universe to be, but I'm a scientist, so I'm going to stay grounded in reality. And nothing in physics shows that like I said, we have domain dependent. We basically have domain dependent theories, and not just that. Here's the interesting thing we're finding out, right? When you do condensed matter physics experiments, and you measure some of these constants like E, H, M, and I was going to come to that later on, like the electronic charge, mass of the electron, Planck's constant. At the level of many particles, we see something interesting happen. We see that we can capture that phenomena at a macro scale, at a macro level with very exact theory, right? An exact theory. And it gives us we can make predictions, and then when we test the theory with those macro like level experiments, when we study those properties in condensed matter physics, we get pretty accurate results. So now these type of constants, obviously the constants that I'm talking, well, some of the things I'm talking about, the charge of the electron and mass, well, aren't those microscopic, related to microscopic objects, right? The electron is a microscopic object. So then, the high energy physicists think that they're the ones who have that's where, the real theory that actually explains the electron is their domain, right? So there you do quantum field theory. And then when you come up with these, and part of that is something called fine structure constant, which is related to these constants. And when you actually use that theory, there is nothing like, it's pretty approximate theory. Like, it's not an exact theory at all. And not just that, we've actually discovered that depending on the experiment, whether you have condensed matter or quantum field theory, whether you probe reality at smaller scales or larger scales. Those constants are different. They have a different value. So now if you're a Platonist, you're going to convince yourself that, look, all that's happening is that, like as our theories will yield more and more exact results, then we'll be able to figure out the value of these constants, which are some sort of Platonic values, right? Out there are these constants in the world. Our science is merely understanding that. But no, see, the thing is, I don't think some of the people are thinking this carefully. There are Nobel laureates who have written, and if any of you is interested, I'm in the process, because I only had very little time to prepare this. I agreed to this last week. It was 1.5, and the semester just started. So I got busy teaching while trying to prepare this. So I'm going to put together this fascinating list of references by including some of the Nobel laureates in physics who have actually worked in this area, who actually explain this. And some of their frustration comes through that some physicists do not understand what they're trying to say to them. They're literally saying, no, the experiments you do is determining those values too. And I'm not saying now, please don't get me wrong, it's not about the human. Like, it's not, again, this is not that the quantum woo thing that you measure and your consciousness is changing. It's nothing like that. What I'm saying is the level, the energy scale at which you probe reality, the systems you form, if you're dealing with a many particle system versus colliding two particles, those constants seem to be determined by that. Like fine structure constant, I think, which has a value of like 1/137 something, which is determined pretty accurately by the macro scale, by condensed matter physics. But when we go down when we're using quantum field theory and we probe, the microscopic world, we're getting values like 1/128 point something, whatever. So what's going on here, right? There's something really deep going on. And not just that, recently we found that to higher and higher, as we add more and more terms in our microscopic theory, in our equations, they're actually not even matching anymore with what we're finding. So, and then the physicists declare, oh, that means there's new physics here, maybe another unification, maybe another law. But there's something else going on here, and some people just are not. I think this is where there's a lack of philosophical understanding, and there's this belief that they hold, and they filter everything through that belief and keep making the statement, keep ignoring what their experiments are telling us. But that's not everybody, right? So there is a lot I can share. Unfortunately, nobody knows about those physicists. You only hear about physicists who make all these type of statements, who are very popular, science writers as well, and so forth. And there are some Nobel laureates who've done the same. But then there are others who shake. No, you need to pay attention to science.
I understand. It sounds like you're taking like a global view of this non-isomorphic connection, or this lack of an isomorphic connection. But one thing, I'd be interested in hearing your thoughts on string theory. But number two, Newton's second law does a pretty good job of drawing a connection between mathematics and physics and the physical world around us. Maybe it doesn't explain everything, but it does provide in my opinion, quasi-isomorphism between the two, at least on that level.
But can you use Newton's second law at the level of where we use quantum field theory? In terms of, I mean, there we use a completely different language, right?
Absolutely. It's not going to apply when you go to that level, but on the levels that it does work.
Yeah. I mean, I'm not saying, look, I'm saying science is wonderful as it is, right? And there are domain dependent laws, and they work in those laws. And then there comes a point when they start to break down, and then we have to use other theories. And that's exactly what I'm saying with Newton's laws too. They have their own domain. They work there. But then if we are studying phenomena where we're smashing particles, and, there we don't even use the word force. We talk about interactions, and we talk in terms of symmetries, and, in quantum field, and we resort to quantum field theory, and, the Newton laws kind of vanish. Not to mention that Newton laws, Newton's theory is pretty much based on an idea of absolute space and time. That concept breaks down really fast when you go to special relativity as well as quantum field theory. It gets even, and I'm going to get a little bit more into that too, if you don't mind. And
yeah, no, I appreciate your time. Thank you.
No problem. All right, so yeah, in this slide, I guess I talked about it. That all laws are pretty much domain dependent and emergent. Like we see a lot of emergence, but emergence means something different. Like the people who are reductionists will sometimes also talk about emergence, but there's a very different view of emergence. There's a Platonic view of emergence, and then there is another view that I'm going to talk about in the context of an open universe view. So just to make sure that there isn't anything here that's important that I wanted to, I've already mentioned stuff about fine structure constant. So physicists have tried to connect all these different domain, theories in different domains by approximate methods. But the truth is, as some of our, for example, Robert Lawling has written this fascinating book called A Different Universe, where he talks about how at macro scale, like in condensed matter physics, we have exact laws. And he says, look, we don't need to even connect it to microscopic theories. The people who are reductionist or are interested in reductions, they try to reduce it all the way down to what they consider is the most fundamental ontology of fields. But condensed matter physics works beautifully with its own set of ontology. Like, when you study, there are all sorts of phases of matter we study. There are things called quantum Hall effect, superconductivity, and we see these things that unfortunately some physicists resort to giving them names like quasi-particle, things like phonons, things like, there are, gosh, I'm forgetting some of the other things that are in there, but there are these, there is an associated ontology that appears. It's not just the law that we see, but we can understand that those aspects in their own reduction. And we don't really need to go. And that is a more exact law. If you start connecting it to the very lower level, then you end up doing all sorts of ugly math, which mathematicians wouldn't like. It's not even ugly math. It's all sorts of approximate methods, and you're kind of sneaking in a bit of, things that are not part of the equation because you already have access to that higher level. So that's why you can do that. It's kind of like saying, like when the COVID-19 thing happened, and I had some, I saw some physicist friends who were trying to model how the disease spreads. And I'm in my back of my mind, I'm kind of laughing, and I'm like, do you really think any model could capture how this thing is going to spread? Because what is that model even based on? Like, how do you capture that suddenly in a country, if a political thing happens, that could change the way what people's behavior is? So these type of things with models that trying to connect it to some lower reality and generalization is kind of, I'm sorry to say, it's kind of nonsense. I mean, in physics, those models can work beautifully, but as things get more and more complicated, it sort of starts to break down. That doesn't mean that there aren't general regularities, even in human phenomena. There are these general regularities, and they're really helpful to think about. But there comes a point we have to see how those regularities that we are framing as laws have very limited applicability, and we should not think of them in some Platonic way. That's the mistake that a lot of people make.
May I ask you a question? You don't have to deal with this now. You can put it off. But my question is, you've been talking about the pure sciences. What about the social sciences? If science and math, if pure science and math have no isomorphic relationship, as you say, what's the role of mathematics in economics, for instance? And how do you establish causality?
In economics, we run into all sorts of the so-called paradox, and any economic model also, they also start breaking down beyond a certain level. So basically, as you go towards more and more complex phenomena, and I haven't defined the word what complex means, but I think we all have an intuitive idea what we're talking about. The so-called soft sciences, I'll be honest with you, it is a shame we call them soft sciences. I'm going to come to that point. This ties in with my open university.
Also, were you
I think the pure sciences have done great injustice by calling.
Also, were you in Nassim Taleb's class over the summer?
No.
Oh, you weren't. Okay, just wondering.
All right, so reductionism. All right, now for reductionism versus reduction. In science, we work with reductions. It works beautifully, as I've explained, but reductionism is a metaphysical stance. It's a metaphysical stance that the variety that you see around yourself in the universe is in principle reducible to some fundamental ontology. And if you're a physicist, then you have this pomp about you that, oh, of course, everything comes down to quantum fields, at least as far as we stand. And then there are people who recently, there is this madness going around in physics community, everything is information. So now there are people who are thinking that there is some information field that exists everything, and and the laws that pertain to information is going to be the law of the world, right? So this is reductionism, basically. And so that's what I mean, that quantum fields or information field or whatever other ontology you can cook up is associated, and its associated law is supposed to be the foundation to all apparent domain-dependent laws. This fundamental law basically is supposed to unify these patchwork domain-dependent laws into a nice, beautiful quilt. At the end, it's all sewn together in a beautiful quilt. It's just that when we are looking at one little patch, we get lost, but really it's part of this, the big, beautiful quilt. So these people basically are also dreaming, even if they don't outright say it, their intuition is very much based on the idea of a potential theory of everything, which at least in principle, if not in practice, exists. That they, again, in some Platonic world, it exists and they just need to pluck it and that's it. Like once it's discovered, then we will have the complete isomorphism between the universe and this Platonia, the mathematical, this law that exists. And I call it Platonia after a physicist I know who used to call it that. The Platonia is the land of all the mathematical things. Out of that, those that are the laws that pertain to our reality, there's some isomorphism there. Okay, so basically we're fundamentally living in Platonia according to them in some way. Or I mean, if you're not, then obviously the theory of everything wouldn't be a theory of everything. So from that point of view, we literally are in Platonia and might as well call ourselves math, right? And it's Platonistic because we are like the shadows in the cave, in Plato's cave, while there is this perfect form out of which the shadows are created, but nobody really knows how the shadows are created, but I'm going to get to that. All right, so a little bit about wholes versus holism. All right, now the other idea is, and I've already kind of captured it with the idea of a law, an emergent law. Like when you study condensed matter physics, you study a system where you suddenly see that you can capture regularities in a very exact type of a law. So science works with holes. When we study these type of systems, it's like a little mini hole. It's almost like a little mini universe we study. There is something to be said about that. It's a little bit of a approximate universe in itself, in the sense that there are laws in there. It has its own little ontology that kind of meshes really nicely with its laws. And that pretty much, I have a lot of respect for that idea, and that's kind of how I view it too. Actually, I don't know if other people do, but so science works with holes. We study dynamics of isolated systems using symmetry principles. These systems are treated like approximate mini universes with the world effective laws is very much used in physics. So when I talk to you about domain-dependent laws, basically in quantum field theory, we have these little patchwork theories for different types of interactions. We call them effective laws. We dream that one day we're going to find the grand unified theory, the one that lives in Platonia, that's going to unify it all. Then we have complete isomorphism. But the reality is that we've gone further and further away. Even these little patchwork laws have to be truncated to actually make sense, to actually relate to reality. But when we can, it produces beautiful results. So not to undermine how successful they have been, but after a lot of truncation, after a lot of things that we have to do, like renormalization, where we came infinity, because they literally otherwise in their pure form will just give you results that are infinite, and you can't really find the world around us in them. So you put the world in them, we do the experiments, and that's how we apply these techniques, and we tame them. And then for some weird reason afterwards, we declare we live in Platonia. I don't know why, but that's not what the science is telling us. It's the opposite. All right. On the other hand, holism. So we do work with wholes, like I said, we study systems and we see regularities, and they're very useful. But holism is a metaphysical stance. It treats the entire universe. Now, suddenly, a scientist, a physicist, after they studied subsystems of the universe, suddenly got really inspired. They wanted to explain the whole of reality, where they want to understand this law that lives in Platonia. And what they do is they actually declare the entire universe as an isolated. Some of the examples that you'll find, they're talked about heavily even in a lot of articles that are written on science, like popular amongst public as well as papers that are published. The universal wave function. You take quantum mechanics, where we study wave functions that are part of the mathematical machinery, and then you suddenly declare that the entire universe is a wave function, a universal wave function. Or the ideas that were promoted by Stephen Hawking, the theory that he worked on, which goes into the idea of quantum cosmology. And then again, you put bounds on it and you kind of declare it as a whole. And so you can actually deal with it, because if you don't do that, then how do you use symmetry principles? Science very much relies on the ideas of symmetry, conservation laws. So if you don't declare the universe as a closed or an isolated system, then science loses its grip. Like, you can't then extend it to, what are you going to extend it to, right? Some infinity. So that's why we want to put it in a box. We try to put the whole universe in a box, and we give it names like the universal wave function and so forth. Often that existence of parts. You'll also hear a lot of these people who study this and study quantum field theory, when they think that quantum field theory is the most fundamental ontology of the world, the stuff of the world that everything is really made up of. They start making declarations that all the stuff you see around us is an illusion, the Platonic shadow, right? And that only a unified whole exists. Quite often you'll see that these physicists also start to become more interested in Eastern philosophy, where this idea of nothingness exists, like sometimes from the Eastern mysticism related to Hinduism. You hear that the idea of Maya, and which is the illusion, and Brahma, the ultimate reality, but everything else around you is an illusion and a shadow. Again, you could think of it in terms of a Platonistic type of a sense too, but it's very much like that. So a lot of people kind of gravitate towards that idea for a good reason, because they have subscribed to this metaphysics. And again, I want to point out, this is a metaphysical idea. This is not what science is showing us. This is a layer of metaphysics, metaphysical angle that we put at science, but science is not sitting with this metaphysics. This is just us, some of us. The metaphysics has been taken seriously by those who make an ontological commitment to, or hold this type of an intuition to something called mathematical structuralism. I'm not saying everybody is a structuralist out there, but the people who start to dive more and more into this idea, where they start to take their equations, literally the math in the equation, as some ontology. They start to, and then on top of that, they think that quantum field theory is what's offering us, its math is offering us the fundamental ontology. Then I don't see why it's so hard for anybody to realize, because I've been there, done that, that you start to feel like the world vanishes into a ghost reality of structure. So you're thinking everything is relational. Because that's what math is. Math deals with relations. And then you've abstracted away things, because the objects we study in science, like electrons, protons, they never really, they don't exist in our equations. They are an added explanatory layer. Like when we say an electron exists, we do our experiments. Electron by itself is not some math that appears in your equation. spin appears in an equation, position appears, momentum appears, energy appears, but an electron itself is not in the equation. That's an added layer. So when you take your math so seriously, but not really seriously, because as I mentioned earlier, that I don't think these people are realizing what we're doing to the math to actually, do real science. They somehow still keep believing that there is this isomorphism. Then you end up thinking that the entire world is just a world of relations. But the thing is, they don't ever realize that relations only exist between things. Like if I say that there's a relation between, two things, there are two things to begin with for there to be a relation. But then they say, oh, well, the thing in itself is a relation. All right, well, okay, if that is also relational, then I dive down deeper. Then I have to say, what are the little things in there that are, and you pretty much end up going into an infinite regress till you arrive at the point where you say, oh, well, quantum field, this fuzzy, ghostly thing is what reality really is. Nothing in science supports that view. All right. As a matter of fact, like I said, there are affective fields in science. There is no unified, there are mathematically unified theories, but we have not found any evidence for those. There's the grand unified theory that unifies strong, weak, and electromagnetic. There are models that kind of put those together, but we haven't really found any evidence. And and as a matter of fact, this whole thing push towards unification, our particle accelerators have pretty much shown that a lot of these predictions they keep making, going down the route of supersymmetry and so forth. If you've heard about that, we're not finding those things anymore. Not anymore. I mean, we were just not finding those. But some people just still keep believing and believing. And there are other physicists who are saying, look, it's time to move on. Stop wasting time or money doing this. We need to move on. But they don't know what else to do. So they keep doing that. There are hundreds upon hundreds of papers published, which are just all about finding mathematical consistency and holding on to the idea, because everybody in their mind believes that they're going to be the one who discovers the theory that lives in plutonium, while everything else are the mere shadows. And they forget that the aim of the theory was to explain the world. Once you arrive at that ghost world and you take that fundamental ontology of quantum field theory, how do you find the world in there? Because you've abstracted away every object to a relation, and you've abstracted away to the point that even space and time don't even exist anymore. That's one of the issues with holism, right? When you declare the world as a whole, the time itself gets abstracted away. Because if you didn't abstract away time, then time would exist outside the universe. But then you wouldn't be talking about the universe as a whole. So the time has to be built, somehow be implicit to the world. And then if everything is relational, then time becomes very spatialized in people's mind. They're thinking there is some aspect of a relation. And then suddenly, not only do you have a universal wave function or a whole universe, you have a timeless universe. Guess what? That's Platonian, right? That's exactly a mathematical world. Platonism gone wild, right? So, like I said, there's no good explanation in this view why from these quantum field theories the world emerges. So you'll hear these people like cosmologists will say, oh, a long time ago when Big Bang occurred, the universe suddenly popped into existence out of nothing. And then when you poke them, what do you mean nothing? Nothing, things don't come out of nothing. Oh yeah, there were all these quantum fields, the ghosts. And then there was a quantum fluctuation. I have no idea what that means. In our science, if there's something that could be declared magic, then it's the quantum fluctuation of the universe out of a ghost world. And literally they use that language. Even the physicists talking amongst themselves use that language. In our experiments, we never see things just pop into existence as a quantum fluctuation. Yes, we do see new particles are created and particles are destroyed. We know that matter and antimatter can annihilate. So I'm well aware of that, right? But that is not what it means, because those things always happens during interaction. Whenever particles interact, collide particles, then in that collision, they can transform into other types of matter. But never have we ever seen anything just fluctuate out of this supposed quantum field that is supposed to really be the ultimate reality. That's the myth. So a little bit on the ghost world, part of that ghost world, I think this is again being lost in mathematical structuralism or some form of Platonism. The ghostliness is deeply tied to the assumption that all meaningful aspects of reality are relational. That is, there are no intrinsic features to entities. This is really important because I'm about to come to another, I really want to emphasize this. This ghostliness is based on the assumption that everything is in reality is relational and that there is no such thing an intrinsic feature that is non-relational. And this is further defended by looking at the dynamics in a structural way, like the dynamical equations in a structural mathematical way, where you look at the math and you declare that's reality. So basically, when you assign ontology to the math itself, rather than saying that in science, what we actually do is that the ontology is an added layer, that the electrons exist, protons exist, we see tracks in cloud chambers, we use experiments to actually add that extra layer, right? What they do is they literally look at the math and they declare that that math is the ontology. So this is just really bad. So I'm starting to get pretty close to, I don't want to fry everybody's brains here, but there is a lot I could say here. But I just want to point out, I think I've said enough, but that's basically your reductionism and holism, which are metaphysical ideas. And I hope that I made that distinction clear, that reduction and wholes is what we work with in science. That's science. Reductionism and holism are basically metaphysics. And most of the physicists who keep defending this metaphysics in the name of science do not know their philosophy, and they need to learn some lessons in metaphysics. And this is the shame that the same physicists turn around and bash metaphysics too, while holding very strong metaphysical views and defending them, calling them science. It's ignorance at its best. All right, so let's talk about, I didn't talk about physicalism, but physicalism is very much related. It's the same intuition in physicalism. When people talk about physicalism and in terms of theory of the mind and so forth, philosophy of the mind. So I don't want to go too much into that. I could, but basically it's the same relational idea, right? The idea of relationalism ties in with physicalism as well. And the idea is this: I'm going to talk about accomplishments of physicalism, reductionism, and holism. Here are the accomplishments. In the context of physics, time is an illusion, space is an illusion. Universe emerged from nothingness, which means quantum field fluctuation, which nobody knows what that means, out of some ghost world. In the context of philosophy of mind, self is an illusion, qualia is an illusion, free will is an illusion, but AGI is only a matter of time. All right? I hope you realize that what I just said, I was being sarcastic when I say accomplishment. What I really mean is that somewhere down the line, when we were trying to explain the world, which what the science was about, when on earth did we started abstracting away the world to some platonic reality? Where have we gone a lot wrong? I mean, either we should just declare ourselves as mathematicians and we say that we're just going to start doing math, then we should stop pretend to be scientists. We've basically just abstracted away the entire reality that we actually wanted to explain. This is the accomplishment of the so-called physicalism, reductionism, and holism. They're all really kind of related to each other, based on a very relational view of science. And science does not support it. So that's basically metaphysics gone wrong. Compatibilism, you quite hear people. So there are these physicalists who realize that something has gone wrong. Maybe we shouldn't call these things illusion. So they will say, like Daniel Dennett will sometimes say, yeah, we shouldn't, there is free will, this and that. But when you actually listen to these people, they're just playing a bunch of word games. All they really mean is, all right, you don't want to call it illusion. You want to keep pretending there is something. And then you come up with this stance called compatibilism. But honestly, if you really take it seriously, compatibilism is an empty stance that wants to reconcile free will with physicalism, but doesn't really offer anything in terms of explanation other than an empty declaration. Because at least those people are smart enough to realize that, hey, we've kind of abstracted away the world. Let's keep talking about the world, right? But let's also still keep defending Platonism and or this ghostly worldview. So there's also the topic that's really dear to me, which I've been thinking about a lot in physics, is time. Time is an illusion. Crowd explains away time only to put it all into our experience. So a lot of the physicists who are right now making the declaration that time is an illusion then start pushing all that stuff that they can't explain under the rug of consciousness. Oh, it's the conscious experience. It's just an illusion. In our conscious experience, we think there's a passage of time, but in reality, time, but they never really explain how can there be such a thing as a static experience? Nothing ever happens if time doesn't exist. Nothing changes. So how on earth do I even experience an illusion of time? Like, it's just nonsense that people just keep eating up and they don't think about, they don't stop for a second to think that it's just nonsensical. It doesn't explain anything. All it does is explain things away, and they haven't really even explained them away. I mean, they've just, I don't know what those people are doing with that. So the new form of mathematical Platonism goes under the computational reality paradigm. The world is the universe is a computer. Everything is computational. One day we'll have AGI where nobody has a clue how AGI is going to happen. If you question that, if you ever say, I don't think AGI is possible, then you're just a backward person who doesn't know anything about science, right? But really, I'm just going to say this outright. Like, this defense of AGI is basically like anybody saying that, hey, spontaneous generation of life is a very good explanation, right? I mean, till they give us an idea of how on earth the computation, suddenly some light is going to come on in these computations. Just in case if anybody doesn't know what AGI is supposed to be the algorithmic type of intelligence, which is going to be like human, basically algorithmic people like us. All right, so, and this is again, this type of relational view, Platonism gone wild. Max Tegmark wrote a book called Mathematical Universe, which will, if you read that, you will have a very good idea of what I'm talking about, because he pretty much declares the entire universe as some sort of Platonistic computational algorithm, basically. But nobody knows what that computer is. Like, is the computer also an algorithm? Aren't we then going into an infinite regress? I mean, in reality, algorithms run on computers, right? So what is the computer on which that algorithm runs? The Platonic, Platonistic algorithm runs. That's easily, of course, overlooked. We don't have to worry about that, of course. So now I'm going to come to the open universe view. Let's see. So I'm going to talk about setting metaphysics right. Okay, so far I gave you a pretty good idea of how the metaphysics right now is very much Platonistic. Even the ones who say they're not Platonistic and they even reject Platonism are actually, they have a lot of intuitions of that run with that. They just haven't taken their metaphysics seriously enough. So first of all, rejecting physicalism, let me be absolutely clear, rejecting physicalism does not imply supernatural or non-physicalism, whatever that might mean. Rejecting physicalism basically means to drop the metaphysical assumptions that are turning our world into a ghost, to drop Platonism, to take reality of objects and matter and stuff seriously, that there is something that our relations are not capturing in science. Because that is the additional layer, right? The ontological layer is added to the science. It's not part of our equations, but it's part of experimental science. It's not, I'm not saying this is something that's added out of somewhere else. It's part of experimental science, but theoretical science takes it from the experiment. And we add that layer from what we see in our experiments, even though all observations are theory laden, but you know, or not all theories, not all part of our explanations are mathematical. Obviously, there are other working theories in our mind that make that bridge. So I think to set the metaphysics right, here's the open universe view. Why do I call it open universe? Because we should never resort to a theory. We should never ever go, and when I say theory, I mean even interpretively. First of all, we don't have a theory like that in science. So we should not resort to even, you know, having this potential theory that assumes the universe as a whole, like the entire reality. In other words, we should not have any talk of universal wave function ontology. We should not have any talk of, we should not have a talk of fundamental ontology in the sense of reductionism, where everything is reducible to some fundamental ontology. Some ontology might be fundamental to certain domains, but we should not have this. I just want to make sure this stuff is kind of really important. I just want to make sure somebody just tell me that you can hear me and everything is going fine. Sorry if I've gone on for too long. I promise you I'm about to wrap
We
up.
can hear you perfectly.
Thank you. Thank you.
Indeed.
All right. So time, and now you might say, well, what did I just say? I just said time is fundamental, and I just said that we should not have any talk of fundamental, right? Let me tell you in an open universe view, what do we mean by fundamental? When I say time is fundamental in the open universe, I do not mean that in any type of reduction sense, but only in the sense that if you actually study science, philosophy of science, how science works, or anything, you'll realize that the assumption of flow of time is always a priori assumed to every explanation we come up with in the world. Not just that, like try to make sense of reality being timeless. I don't know how anybody could make sense of a world where you see change in any way. I mean, you just have to put it in our consciousness. Even then, you haven't really explained it away. So only in that sense, I'm saying that time is fundamental, in the sense that Platonic type Platonism is a timeless metaphysics. Open universe metaphysics is time-based reality. All right. And I'm not giving any definitions of time. All I'm saying is there is such a thing as flow of time. And that might even be very different at different levels of emergence, at different levels of reality, be as fundamental to that aspect of reality. So I'm not saying there's some fundamental aspect of time which only physics can tell you about. I'm just saying that the flow of time is a priori assumed, and we cannot explain it away. And just to be clear, even special relativity, there is such a misconception that, and it's propagated because Einstein said things about time being an illusion and so forth. But special relativity did not abstract away time as is commonly believed. Special relativity is an operational theory, right? It works with operationalism. It works where we already assume that there are these clocks, and we talk about time, but it does not deny the reality of time. But it only, so I would say the operationalism tells you what the limitations of that theory are, as just like with any other theory, there are limitations. The flow of time is perfectly consistent. There's no issue there with proper time in special relativity. And some people think that space and time were merged into the same aspect, and even I forget which physicist said that the space and time has now been merged into. We talk about spatializing time. No, there are actually some pretty good philosophers of science and physicists who have clarified this point, that space and time are not on equal footing. Special relativity. That's a misconception. They are quite different. Proper time and proper length are two different things. They're not one and the same thing. We have not spatialized time, just to be clear. And the other thing, to set metaphysics right, obviously, if this open universe time view, I'm saying time could not have had a beginning. It just makes no sense. We don't live in Platonia, where time is some illusory thing. I mean, we can't even explain what time would mean to Platonia. All right, so next thing is we need to reject the causal closure in the sense that I talked about earlier, but that does not mean rejecting causality. Of course, there are causes to things. Causal closure doesn't make sense even if we assume the universe as a whole, because there can be no cause of the universe itself that simply exists as a whole. So that would be an issue still for the Platonists. Rejecting causal closure doesn't mean rejecting causality. Emergence in open universe metaphysics means something novel. When I say emergence, I mean, just like I talked about, that when many particles come together and we see phase transition, new phases of matter emerge with their own kind of interesting ontology and so forth. That's what I mean by emergence. The human mind emerging, that's another thing. When the emergence of life, emergence of mind, these are all examples of emergences. So emergence in open universe metaphysics means something novel, entirely different from physicalism. Physicalism talks about supervenience and so forth. I don't want to go into that. But in physicalism, you stick to some reductionism-based view, where everything is fundamentally reducible. But in open universe view, everything can be called basically fundamental, if you want, if that makes anything. Everything is novel. The universe is never the same. No event is ever the same as the universe unfolds. And it's not even unfolding. It's actually in a process of, the better word, I don't know what else to use, would be creation. There's always a process of creation going on. The past, future, and present aren't just sitting there in some Platonia, but it's and there's local, the creation is going on all sorts of local level. When we come up with an idea, that's a creation, that's a novelty. When phase transition happens, that's a novelty. Even though you may be able to recreate that phase transition again, and we do, that still doesn't take away that it's novel in itself, that it has its own fundamentality and not reducible to the quantum field theories or whatever else. How fundamental is causality? I don't want to go too much into causality. This is something that I have lately been looking more into and trying to understand causality. Fundamental, not in the sense of reductionism again. I definitely don't think it's going to be in the sense of reductionism. I also think that we need to be open to the idea. I don't think there's anything wrong with keeping, and it doesn't go in any conflict. Science doesn't have anything to say in this, to being open to the idea of new causes. And I do think when we say something is novel, we are saying that causality is novel as well. There are new causes that are emerging. Once you leave reductionism, even causality becomes novel in that sense. And what that means, I don't know, but that is the line where people, when they start thinking about the open universe, you need to take that seriously. Is there a part of reality? Are there aspects of reality where causality breaks down? I don't know. I mean, like I said, it is emergent, so it doesn't make the open universe is saying to us that it is like there is no reductionism, so it is always novel. So it kind of goes down. So I shouldn't really put that question mark. Causality breaking down would only make sense if you talk about reductionism being the paradigm. But if reductionism isn't there, then that concept kind of is meaningless. Causality breaking down. Causes emerge in the universe is what I'm trying to say. In the open universe, novel causes emerge. All right, almost there. Let me see if there's anything else. As a matter of fact, there are some physicists who've tried to go along this route. Lee Smolin is one of them. Others have, like I said, there are many Nobel laureates who've tried to point these things out, but nobody's actually seriously tried to take the metaphysics of a time-bound open universe seriously, other than the only one I can think of is Lee Smolin and his collaborators. And I'm not saying they have given us any theory of everything, and I feel like Lee Smolin still has a lot of baggage left over from his time of reductionism, but he's really making an attempt. And I think this is something, the reason why this topic needs to be presented is that there's a barrage of problems that are opening up in physics, and they're all framed very much in the current paradigm. And people aren't even thinking around it. They still keep thinking in the same way, because the problems are always framed by the metaphysics that you hold. And they don't even realize that. So this, once you start thinking about an open universe, the problems that emerge with it become quite different in nature as well. So this is where I think a lot needs to be. We need to think about it. So finally, metaphysics set right. We do not live in a ghost reality where have we gone wrong? Does science need to change? Well, science is doing what it's doing. It's the metaphysics, it's our interpretational angle that needs to change. But science has been telling us something, and we just not listening. We're just been kind of blinded by our beliefs. Space is fundamental to an understanding of the diversity of the world. This ghost world seems like the space starts to disappear away. But at our level of reality, space is a reality. We live in a three-dimensional world. We cannot ignore that. That doesn't mean that space may not have its own emergent features at different levels, but I don't think we'll ever be able to get rid of space either. In other words, there is no time when there were just quantum fields. That would be a ghost world, because we wouldn't know how to create how the world would emerge out of that. Somebody can explain it where there was no time, just static, whatever. quantum fields, and out of that, the world popped out. That's as ghostly and as magical as it gets. And those same people make fun of other people for having magical thinking when they say physicalism or reductionism is wrong. So to understand space and time, we need to understand matter. My big hunch in all of this is we have ignored matter. I'm actually going back towards more materialism, but I'm also saying materialism is not what we think it is. But Aristotle had some interesting ideas. His idea of materialism was very different. I'm not saying we go back to Aristotle. He was pointing to something, and there are people who are actually working now on substance ontology in when it comes to causality as well. We need to take this seriously. So I'm not giving any theory here. I'm just saying this is my hunch. I think we need to we've gone away from matter. We've gone away from material world. We need to come back to it. Science is not mathematical. To set it right, we need to we need to pay attention to this. Science is not mathematical. There is no isomorphism in science and mathematics. I think I've said enough. I don't want to repeat that. Let me just quickly see if there was any other important point, but I think I've pretty much covered everything I wanted to, and I think I'll just stop. I could go on, but I think that's enough for today. All right, now I'm done. So any questions, comments, open for discussion?
I wish to say something.
Let me just get rid of this here. Yeah, please go ahead.
I think the trouble started with David Hume when he said that everything that we know about the world is either by senses or by inference. And causality is something that we do not know there's no sense that tells us of causality. And also there's no inference. Ergo, causality is a myth. As we all know, battalions of philosophers tried to solve what was referred to as Hume's problem. And I think that it was Karl Popper who first said, let us accept it, that Hume was right and there's no solution to that problem. The problem is that we cannot, and not only that we cannot conceive of science without causality, without the concept of causality, but I don't know if we can conceive of any feasible undertaking in this world without causality. And the question then is, what is causality? And I have to say, for me, it is magic.
Well, other than the magic part, I agree with you because I don't know what magic means, but clearly the world is interesting when we look around us. If the world was magic, I wouldn't be able, look, every morning when I wake up, the fact that I know that I'm going to go to work and I have to do A, B, C to get there, and I actually managed to get there means the world is not magic.
The very fact that you wake up at all.
What's that?
The very fact that you wake up at all is already something to wonder about.
I will say one thing, though, that in the open universe view, which I haven't really gone into the idea, there are some ideas in ontology that I've been kind of toying around with. When I said that new causality emerges in the world, one might say, well, where does it emerge from? Some magic land? I think our failure is that when it comes to ontology, I'm just going to give a quick thing on where we do math, where math works. There's a layer of reality where distinction, there's world. The sort of thing that I said, ghost world, the of reality where that differentiation doesn't exist. I'm not saying those are quantum fields. I'm just saying that there is maybe a better way to think about it is that between actuality and potentiality, like some philosophers like Bergson, the Whitehead, and I'm not again saying that I agree with all that they were saying, but I think they were thinking about the world in a world in time, like where time is real and fundamental. and they try to grapple with these things. So in that sense, what I'm saying is that it's not magic, that there is something about the world we're missing. Magic would mean that something just comes out of nowhere, right? And that can't be like even randomness. Like, you know, some people will say, oh, well, maybe it's something to do with randomness. Randomness doesn't get us anywhere. There's a beautiful idea of autodidactic universe, that when the learning, like, think of the universe as learning new things. So how does it learn is the thing we need to ask ourselves, but not in the sense that learning is more like there's a platonic realm in which somehow either our consciousness is moving forward and I don't even know, like, how to make sense of in a platonic reality where everything that you could possibly imagine is already there. We have to get away from that and ask ourselves, how does the world, how in this open reality where time is fundamental, does the world learn? And then I guess Sam. Hi there, I'm glad you made it. Good to see you.
Thanks for the talk and the invite. And I guess though my first question would be that you reject the idea that there is a universal wave function. It seems like that it confuses me, because then what do you think these other systems are? Like, if the world isn't completely wave function, then logically you seem to be implying that there are things which are not described by a wave function. So you would maybe say the whole universe is a system which is not described by a wave function, but that would mean that some of its subsystems are not described by a wave function. And the idea of the universal wave function is simply that everything evolves unitarily and everything is a quantum system. That's if you take those two things on board, then that's what leads you to a universal wave function. So yeah, how do you bridge that gap? Which systems are not wave functions in that case?
So the way I look at it is that even the statement of unitarity, like, that assumes that we can talk about the universe as a whole, right? But if the universe is not a whole and it's not a closed system, then, you know, I don't even know, like, how, like, it becomes kind of meaningless to even talk about, you know, I mean, like, what evidence is there that the universe is a whole, is, I guess, what I would say. And I don't see any reason to believe, yes, that, you know, when we look at even the Big Bang Theory, you know, we know that the Big Bang Theory isn't really the origin of the universe, in which theory of origin, we know that it's the evolution of a universe. We can go only so far back. For as far as we know, that might have originated in somebody's lab, you know, like in a much bigger universe. Our universe might have somehow been created, which kind of brings me to my beginning slide, where I kind of created that using one of the AI tools of somebody creating a universe in a lab. But
I haven't seen that.
So the idea is this, that yeah, I mean, like, I don't have to subscribe to a metaphysics. There's no reason, because everything about science is domain dependent. I would actually strongly recommend, because there's so much I wanted to go into, and I feel like I'm going to write more on this, on all these topics, to actually read some of the people, like physicists who've actually written about it, like Robert Lawling, Leggett, Philip Anderson. I mean, I can name a bunch of, like, there's so much literature that's there to think about physics itself and ask yourself, how does physics actually work? Because even non-relativistic quantum mechanics has its limitations. You know, so what do we mean when we say we extend that theory to the whole universe? What is the basis for doing that is what I don't understand. It's pretty much
even that is not, I mean, it could be that the universe is open. I would agree, I would disagree with that, but even if the universe were open, that wouldn't mean that the universe as a whole isn't wave function. For example,
but you just said whole again, right? You said it's open, but it's whole. To me, that's a contradiction right there. The universe,
right? But I mean, regardless, I'm just saying, regardless of all of those issues, regardless of whether it is open or closed, it could still all be wave function. It's just like the idea that, as I said, the idea that the universe is only wave function or something like that. It's just the idea that everything in the universe is described by a wave function. So all the matter in the universe is described by a wave function.
But
and therefore,
all right. Could I read something a little bit from, I actually had a feeling that we might come up with that by David Wallace, maybe just a quick thing. There's a paper where he wrote an article called Against Wave Function Realism, which I just came across a few days ago, and I was surprised to find that actually by David Wallace. It actually says this, all right, it's just a brief thing. It says in toy non-relativistic quantum mechanics, the position representation has a central role in the formulation. Here, I'll tell you what, I'm going to share this. I actually have it here on my screen. It's really brief. It's and that should actually tell you what I mean, that even there is a domain dependency there, and there isn't a case to be made. Here it is. It's right here, just this first paragraph. I'll just read it out loud too, and you can feel free. So in toy non-relativistic quantum mechanics, the position representation has a central role in the formulation of a theory. So it is not difficult to imagine making a case for preferring it metaphysically. Then later on, he goes on to say only bosonic field theories can be represented as wave functions on configuration space. Others, the fermionic field theory that represent electrons and quarks, and so are central to a quantum mechanical description of ordinary matter, possess no such representation. In conclusion, wave function realism seems to rely on features of toy non-relativistic quantum mechanics, which, far from being universal features of any realistic quantum theory, drop away as soon as we generalize. At least pending very substantial technical work, we should treat with grave skepticism any suggestion that a metaphysics based on these features of toy non-relativistic quantum mechanics has any real bearing on the metaphysics of our universe. And later on, non-relativistic quantum mechanics, in which electromagnetic radiation is wholly absent, could not support complex organisms anything like us.
Yes. Yeah, well, that makes sense. And it's not really a case against many worlds, which is what some people will read it as. I mean, the case for many worlds, I just made it briefly, is just that everything is a quantum system. And the theory has universal reach in that regard. I think in this aspect, I agree with Wallace that we should prefer, well, I would say we should prefer observables and treating them as the operators that they are, which is in essence what Wallace is doing. In quantum field theory, you have a bunch of operators, they are functions over space-time, and that is your theory. And as Wallace is also keen to point out, it's difficult to make sense of the theory from an ontology first point of view. Like,
so would you consider yourself as supporting reductionism in the sense that the fundamental ontology then would be the wave function, or whether it's the quantum field or something like that?
Yeah, I don't know what the fundamental ontology should be. It's just the Everettian approach is just to say there are unnecessary elements in the traditional formulation of quantum theory. Some Everettians will then go into wave function realism. I think it's necessary. I don't think we have a very good understanding of what the ontology is of quantum field theory. You have again, I would point right back at Wallace and say I agree with him.
But I think then that also points to this, for the same reason. I think we should not really, where quantum field theory works beautifully where it's supposed to work, and then we take. See, here's the thing. Like, I am a realist, but I don't feel like we should feel obligated to take any of our mathematics as representing reality. There shouldn't be. That doesn't make us an instrumentalist, because we do add that ontological layer, like the stuff from when we do experiments. At some point, I think we have to make a strong commitment to our experiments. But what I would invite you to do is, despite of, I'm going to invite you to, no matter what it is, to think about what I'm saying about the ghost world here. So see, this is the problem that I've grappled with, because the more you start to abstract away and go towards mathematics, you realize that if we are saying, if we are making such a ontological commitment to the mathematics there, then I don't know how the world emerges out of that. Like, yeah, we just assume that it does, but I think the more you take it seriously, the more you realize that something has gone wrong. So what I would say is that, and this has been pointed out, and I can share some other papers too, that in a lot of ways when we use quantum mechanics, there are lots of things where we smuggle in classical worlds, like we are assuming the space. Like, for example, if we have a position representation of wave function, we're already assuming three-dimensional space exists. And as far as we know at this level, the space is pretty much classical in the sense of non-quantum mechanical. I don't mean classical as a Newtonian classical, even though in non-relativistic quantum mechanics it is kind of like that. And anyway, I'll see if maybe we can discuss this at other times too. But
yeah, I don't want to keep the other people from asking their questions, but thanks.
Yeah, John, you have a question? Sorry.
Sure. Two things. The one was I was going to ask you about Popper's three views on human knowledge, and also maybe come back to Chen bit and talk about the God hypothesis for a second. But what do you feel? What is Popper's criticism of the Copenhagen framework? Is it all about instrumentalism? And what do you think about his critique of instrumentalism?
Is that a question to me?
Yeah, that's a question to you.
I mean,
the second
all right, I'll be honest with you. I'm not going to claim to be any type of Popper expert here. I'm very much inspired by what I took from Popper, and even if I said those things, I wouldn't know. But what you were asking, what my critique be about his three worlds?
No, I'm talking about you seem to mention as well that you reject instrumentalism to a certain extent. If you want to maybe explain that, is instrumentalism an obsession with formalism and with mathematical Platonism in your view?
Yeah, my view is this: that instrumentalists kind of cheat quite a bit. Like, why is an instrumentalist even doing science if that wasn't to learn something about the world? Are they just mathematics that are pretending to be scientists? And then when their science works, what exactly is going on? Why is the science work? So one cannot defend instrumentalism based on how science and how well science actually works. So there's definitely a reality out there, and we also know that reality, that when we talk about that reality, we are never, like, there's no such thing as like a direct, it's always through our experience. It's always connected to theories, to what we make of the world. But there is a world out there, and the mere fact that science works, the mere fact that every day we learn something new about the world and we're able to work with it better sometimes, well, sometimes worse, sometimes better. But if you look at the humanity that we haven't been wiped out, means that we are learning something about the reality out there. We just don't have to be too literal about it, as in, but I think there are very good reasons to reject instrumentalism, and I don't even I don't even take the ideas on idealism and stuff at all. I mean, they're not even worth on it because of what I'm saying. Like, I mean, are they because some of those people are just putting, whether it's solipsism or whatever. I mean, what are they doing? Just putting all the reality in their mind and saying we're studying. I don't know what these ideas. But instrumentalism, I think there are very good reasons to just outright reject it.
Okay. Papa would agree, of course. The other thing was because Chen before said something like that science doesn't really deal with along the lines of science doesn't deal with the God hypothesis. But Dawkins rejects this, and he formulates the God hypothesis as follows: there exists a supernatural intelligence who deliberately designed and created the universe and everything in it, including us. Is that something that science could, or theoretical physics could try to solve?
Honestly, you don't even need to go to science to reject all that. You really don't. And I never had to read Dawkins or any logical proofs of God to reject. I'm an atheist. I mean, I'm not even an agnostic. I'll just be outright. The very idea you presented of God there, I'm opposed towards that. For the same reason, I'm an atheist towards the existence of Santa Claus, the little goblin that might live under my floor. Do I need to be agnostic about the goblin? Because the simple idea is this, right? Unless if I'm willing to invent my own God, I usually take because I'm an atheist, I look around and look at the people who are presenting views of God, and then I take and evaluate, right? I'm not interested in coming up with my own. I'm not a prophet. I'm not in touch with anything like that. So why should I come up with anything? So when I talk to people who defend that idea, a lot of times it'll be in the framework of a religion. And literally all you have to take their ideas of absolute knowledge and how, because most of the religions then obviously for them, the God is meant to be something that's a giver of some sort of knowledge to humanity, and there are some absolute truths and morality. All of that is so easily refutable just based on the fact that somebody's claiming that somebody out there has absolute knowledge. And they're in touch with us, because you can pretty much just start dissecting those books and come up with all sorts of criticism of everything, where we've actually got better ideas now in terms of ethics and morality. We are way like, in somewhere else, just purely based on ethics and morality, we can reject those. Science doesn't have to do with any of that. And then the creator God again means, well, we know that there are all those ideas. Okay, then who created the God? Those are really not.
Well, I completely agree, but I was just thinking, Jen, you want to come back on that? I was gonna.
I don't know why are we going there?
But I'll tell you one thing. The open universe is stranger than we think, and it's not a very simple thing. There's something that the universe itself seems creative, and I hate to use this word that's always used with, that has this religious connotation. The universe, even the history of the universe that we have access to, it seems like, it's in a process of becoming. It's interesting in philosophy. There's this idea that comes from all the philosophers like
I have something for you, John.
Sure.
I might have. There was a time when I was a young man, I think many of us went through that phase, when I was Carlos Castaneda enthusiast. And he reports that in one of his encounters with Don Juan, his mentor, he asks Don Juan about his metaphysics, no less. What do you believe in? Or what does a warrior believe in? A warrior, that is the thing that Don Juan is trying to train Castaneda into being. And he says the belief of a warrior is in the endlessness of the universe. I never quite gave it too much thought, but it fascinated me, I must admit.
And just one comment on that. I mean, to me, the most awesome thing is that the universe, not only is it just like when I say that the universe might be stranger than we think, I mean, I think in the sense that, like, there is no way for us to predict what the future is going to be like. The only way to ever find out, instead of, like, I could cook up all sorts of things and then that they might sound magical, and I really shouldn't. The only way to find out is travel that path and try it out. And if there is this type of inherent creativity, then we all are participants in that. Every event is participating that in its own way, not in equal ways. Like the humans can do stuff that electrons can't do, and I can do more than what, different things that my cat can't do. But to figure out, I mean, I might have rejected the idea of AGI, but I'll be honest with you, my ideas are even more radical. I think if the future is open, we don't even know what the future holds. Will we create hybrid intelligences? I'm open to hybrid intelligences. I don't know, but I think there's something about the substrate that we have abstracted away. We need to not ignore the substrate. This whole idea in the computational paradigm of substrate independent laws and so forth, we need to reject that. We need to explore and stay pretty close to the substrate, but also realize that that substrate is becoming. We're also, we're part of that substrate. So So we don't know. Maybe one day we will create. I mean, one of the things I want to know is how to create a universe in the lab, and maybe there isn't such a thing. Maybe
How to
there's
create
something
what?
possible.
Create a universe in a lab.
Oh,
There,
yeah.
I got to share my photo once more of my screen there. I have to see. This is my last page. I have to just share it once. Dream of a creator is what I call it. I created this using I forget what this thing is called. One of the art, where you kind of play around and you create art. But anyways, I created this. This is somebody who's
It's you
this
creating
looks
universe.
something like a living cell. This looks like a universe. And then the eyes are closed, and there's also emotion involved. So it's all just not in just lab, and there's that aspect to it.
Sadia, what do you think of Lawrence Krauss as a physicist?
Honestly, I probably shouldn't say anything because I don't have anything good to say. So
okay.
Yeah,
Well,
this whole
said
idea
right
again.
there,
He's
okay.
one of those people who've been propagating the universe from nothing. It's just one of the most ridiculous things I've ever seen, and how much of public has eaten that up, and even scientists. Like it's really disappointing. And these are the type of people. Again, this is this kind of see, the problem is there are these few physicists who are well known because they are staunch atheists, even though I'm an atheist too, but I'm not that type. That, one of my experience with going to philosophy groups is everybody wanted to discuss God, right? That's the first thing they wanted to discuss for some reason. That's always a favorite. And then, so people always listen to all these physicists who have something to say about God. And then they make these claims, and then they become popular because it pisses off religious people. And then the atheists are like, yeah, bash God, So then they become popular. And then some of these people also happen to be stuck in this old era of logical positivism. They ditch philosophy, they make fun of metaphysics, yet, like I said earlier, they keep promoting their own metaphysics, not realizing that it's metaphysics and not science that they're actually selling.
So if the universe didn't come from nothing, are you thinking of the universe? Is there a beginning of time?
I don't think there could be a beginning of time.
So universe is eternal, yeah, in a sense.
Because the thing is, to me, that idea is pretty much the same as saying that when people say, why is there something rather than nothing? I think that's just a bad question. So even saying that could there have been a beginning of time, I feel like that's just a bad question. You really
it's a self-contradiction, because
Exactly.
beginning and end are beginnings and ends are within time. So the only way that there could have been a beginning of time is if it was in some kind of meta time.
Exactly. That's what I mean. Sorry. Thank you for making that.
At your service.
And then, sorry, a few other questions. I think somebody by the name G.
No, fine. Thanks a lot.
Whoever, I don't know, G. Who's G? Or maybe I'll go to Brandon while I don't know if you're trying to just unmute yourself. Brandon, you have a question?
Sure. G's here. Go ahead, G.
Yeah, go ahead, G, because I know you were there a while back, and then I saw, I don't know what happened. Sorry, G, go ahead. Sorry to call you G, but.
I just wanna comment on the open universe, this evolving ontology. I think there's gonna be another constraint here, which is you can't have a lot of novelties, but then at the end of the day you need to kind of simplify them and reduce them to something so that it's compatible with your own survival. Like it's like for example, it's like a person with ADHD, and he may be very attuned in capturing these little things that may be called novelties, but then at some point this person's gonna face like a survival issue because maybe cannot function in a certain way that brings economic benefit or something like that. So I think there should be like a because I think in your slides you talked about how you ejected the this computational side of computationalism. I think there's another way to look at it, which is like, you know, there can be like a limit in this physical processing power that you can compute all the relations. You kind of need to narrow things down and simplify things, and I think so that the organism or the person can survive. And I think there are some works in like thermodynamics that talked about these, like how much work or how much energy do you need like to process a certain amount of information, and just wonder what's your opinion on it.
Yeah, I mean, I'm trying to understand what you're actually asking. Like the open universe, again, doesn't mean that there aren't any constraints. It's actually quite the opposite, right? The view is that there are all sorts of constraints, and constraints allow useful work. This is, I'm kind of borrowing some ideas even from thermodynamics. There's actually a really beautiful book by, no, I'm probably not going to be able to read it. I'll have to share it in my list. I can't remember it, but this whole idea of how constraints, different types of constraints allow new type of work to be possible. So, so in an open universe, there is no limit to what sort of constraints you create, but time puts a limit in the sense that not everything can happen at once, right? The open universe is a constrained universe. There's a process. The process is very important in an open universe. It's not a platonic realm where everything is given. And even in the platonic realm, like, I think, you know, for them, that's a challenge. Like, how do you make sense that there is actually a process to everything? So yeah, I don't know. I mean, I don't see any issues with that. I think in that sense, I think it's fine. The open universe view, I don't see any problems. And I mean, I would love to go into, I won't have time, like how, like I've already kind of thought a lot about how to make sense of morality and ethics in an open universe. That in itself is a fascinating topic that I could probably say a lot about, that I've been thinking about. So in that sense, the morality is not going to be relative, which relative morality really makes no sense. And it's also not absolute or objective in some sense. It's not like the moral laws live in some platonic realm, right? So, but it's an emergent morality. And that's a very different type of a concept, but I don't want to go too much out a lot. And then because there's always a process, as humans kind of, as humans are in this process of becoming, we work things out, and, you know, things can work out good, things can work out bad. We need to be aware of that. So there is a sort of uncertainty to reality. There are no formulas or any type of rules that we could discover that would guarantee our survival, or that says that we will eventually die out. So like I said, the way we're going to live in this, or we do live in this open reality, is to travel and become. There's no predicting too much ahead of time. That's what it means. But the nice thing is we can predict at least enough to, you know, we make things work. You know, the science works beautifully, so it does give us this predictability, you know, this power to make predictions. Science works, but beyond a certain point, there is an openness to science. So a part of science is discovery, but a part of science is also invention. As we start to create these new phases of matter, we're going to probably reach a point, we're going to start creating stuff that may not exist. If it hasn't already happened, then we're going to start doing stuff in our labs that doesn't happen out there in nature, but only happen because we exist. And that's the neat thing about it, is our reality. Because the opposite view just doesn't pan out. I mean, and what other view is there then? All right, Brandon.
Thank you. I said it before, and I'll say it again. This whole conversation has been extremely fascinating, and appreciate you being here. So thank you. I respectfully wanted to ask you a quick question. I think the idea that you said that you'd like to create a universe in a lab, I think that is absolutely fascinating as well. But respectfully, if you could accomplish this, would it be plausible to call you God?
Yeah. But I'll tell you one thing. I'm going to give you even a more maybe a ridiculous answer to saying I want to create a. I think that every time we even create a phase transition, that's basically a mini universe. It's just that it doesn't persist like ours to do anything more interesting than. I think that is the mini universe here. Every time we create a phase transition in our lab, we have sort of created, you know, if there is a word to be given to a universe, that's to me that's it.
Do you believe in the multiverse, or do you have any thoughts on the multiverse that you feel comfortable sharing?
I think the only thing that I can think of that is if time is the reality, and like there's no way that we could talk about a timeless reality. Then, like I said, if let's say if universes can be created, and again, when I use the word universe, I'm literally just saying some sort of an system that is autonomous enough to take a life of its own. But how autonomous, I don't know. Like I don't have the answers to this. But that's the only type of, I don't even want to call it a multiverse. That is more of a, and I don't want to get too sidetracked, but I have some ideas because I think the idea of space fascinates me so much. I think the idea of space ties deeply with identity, what it means. I still remember, I sometimes ponder over the whole thing John Wheeler, famous physicist John Wheeler said, and I don't know how serious was it. It seemed like he might have been a bit serious, a little bit at least, about the single electron universe. I don't know if you've heard of that.
I'm not too familiar with it.
But the
I've heard
idea,
it, but not.
the idea that there's only one electron in the universe. But anyways, you know, that always comes to my mind because I feel like that's where when you start to abstract too much away is what happens when you come across. To me, when you start thinking like that, it should ring a bell, an alarm in your head. Something has gone wrong with your head. To me, that's the sign of that. To me, the idea of space, I feel like space is one of, so I'm going to say this. I think this whole idea of unification is bad. All right, I forgot actually there was a slide I really wanted to, that was one of the things I was going to say in the whole metaphysics, putting metaphysics right. The open universe idea gives up on unification because the idea of unification again takes the universe as a whole. So we could find things places where we could find mini unifications as we have done, but the idea that there is a unified theory that exists underneath it, as I hope that whatever I presented made a good case against it. So then one might ask, what do you mean? So is there a dualism, pluralism? What do I mean? What I mean is that I think that there is a certain, that just like I said, that time is fundamental. I think that some sort of a dualism or pluralism will always be fundamental, because if it wasn't fundamental, then we would be in a ghost world. Then ghost world would be possible. And I don't think that will always be our a priori, like in all our explanations, that will always be there. That doesn't mean that there may be aspects of reality where things get really fuzzy, because they do. That's what science is revealing us. But that means that this classical quantum dualism, I don't think we'll ever be able to get over this. I don't think this is going to go away ever. Because if it did, then we would be in a ghost world. And ghost world, it makes no sense. The world cannot come out of a ghost world.
Well, what do you think happens inside of a black hole? Could that be considered a ghost world?
That's too specific of a question. Like, I don't think that would be, even if I said what happens inside, I don't know what happens inside a black hole. There's a simple answer.
Okay.
Yeah.
So we are running out of time, unfortunately, but thank you so much, Sadia, for that fascinating conversation. And we're so thankful that you've joined us and you gave that. So if anyone would like to get in contact with Sadia, you can find her on Facebook. And you can also send an email to our Karl Popper, and we can get contact details.
Yeah, that sounds good. Yeah, if you need like a reading, some sort of a recommended references, what I was talking about that I couldn't get into by all sorts of physicists, philosophers and stuff, I'd be more than happy to share. I'm going to put all that together.
Wonderful, thank you. So now we are moving on to the next session. So the next session we have Hien, who will be doing a presentation. So Hien was a student of Joseph Agassi. He is in Israel at the moment, so it's 1 o'clock in the morning right now. So we're very thankful that you've stayed up late. So Hien is going to be giving a presentation, which is going to be followed by a discussion. And it's a presentation that's very close to his heart. And he's chosen the following topics, which is politics, anti-politics, and the strive for peace. So I'll hand it over to you, Hien.
Thank you. Like always happens in such cases, I don't know where to start. Maybe I'll start with some of the crude facts concerning the Israeli-Palestinian conflict, facts which I suppose everybody knows they are on public display. First thing is this, that this conflict belongs to an unholy category or class of conflicts that are known as intractable conflicts. And within this sad category, I think that the Israeli-Palestinian conflict is keeps a world record, at least in modern history, because there were longer conflicts than that in older history, but I don't think in modern history. And there's an entire literature on the question, what is it that makes intractable conflicts intractable? And I want to relate to that, but maybe before I do, let me invite anybody who wants to jump in. I don't know how much time I have for the presentation before questions are permitted. So Elise, if it is okay.
Of course, like you can do it in any format you like. So we've set aside 2 hours for you. So take your time and whatever you want to do, that's fine.
So I want to invite everybody to jump in already from the start whenever you feel so inclined.
Okay.
Okay.
I'm going to give a very simple answer to the question you just posed.
I did? Okay. What is it that makes, yes, please.
Religion.
This is the popular answer. This is the most common answer. And the truth of the matter is that there are religious people all over the world, and still there are countries that live in peace with each other and countries that do not. So I'm not saying that we should let religion completely off the hook, but it must have accomplices in order to perform that. And I wish to put forward a thesis to that respect. And my thesis is that at the root or at the heart of every intractable conflict is the aversion to politics, anti-politics. And I hope this will not be an insult to the intelligence if I go back a little bit to say what should be, in my opinion, of course, considered politics. What is politics? And ergo, what is anti-politics? Of course, politics is the realm of public affairs and public interests and public needs. This is the definition of politics. And it is interesting that all over the world, but especially in Israel, when we want to say of someone that he is in the political realm, but is acting from non-political or even anti-political motivations. For example, he wants to, he takes care of his own group or his own party, etc., etc., etc. We say that he's acting of political motivations. And this is a misuse of the very word politics. So I am not, my agenda is not to redeem words. But this word needs redemption because we need this word. We need this realm, and we need a word to describe it. In Hebrew, they use another word to describe it, which is really the translation of politics. It's called mediniyut or medina, statehood. At any rate, sorry for the, sometimes I get lost in my own thread of thought. Since politics is the realm of public affairs, the very first question that arises whenever anybody wants to deal with politics, to talk about politics, is what is the public? Which public are we talking about? Who belongs to this public and who doesn't? And this question in Israel is taboo. It is against the law to ask this question in Israel. And within the Palestinian authority and within the Palestinian leadership, it is also taboo. Everybody takes it as goes without saying that there is no Israeli nationhood. I don't know how many of you know this, but Israel does not recognize the Israeli nation. According to the Israeli political ethos, there is no such thing as an Israeli nation. And there's also no such thing as the Palestinian nation. And the same outlook or the same ethos is accepted unquestioningly by Palestinians. So I find this amazing. People in both in Israel and in Palestine, and people all over the world sometimes describe our conflict as a conflict of identity. And I agree, but nobody asks, how can there be a conflict of identity? If my identity is one thing and your identity is another, why should there be a conflict between us? The more identities, the merrier. And the thing, I think, that the conflict between Israel and the Palestinians is a conflict about the question, who are the parties of this conflict? Now, it sounds like a joke, I know, but I mean it seriously. And with your permission, I will explain. The question is, the question is on both sides, concerning Israel and concerning the Palestinian entity. So let me start with the Palestinian entity. It doesn't matter where we start. The question is there such a thing as the Palestinian nation? Is the Palestinian nation part to the Israeli-Palestinian conflict, or are the Palestinians not a nation? Maybe they are a group, a people within the wider nation called the Arab nation, or the pan-Arab nation. Now, the vast majority, I mean, almost everybody, with a handful of exceptions, of people who speak about the Israeli-Palestinian nation, both in Israel and Palestinians, express the view that the latter is the case. The Palestinians do not comprise a nation. They are part of the Arab nation, which I think it needs to be said does not exist. I don't know if you know, but there's no such thing as the Arab nation. Just like there is no such thing as the Hispanic nation. There are many countries in the world that speak Spanish. Nobody ever suggested that all these different nations are in fact one nation just because they all originate in the Spanish language and the Spanish culture. And the same thing goes for all the English-speaking countries. I think there are at least 5 or 6 or 7 of those, right? And nobody in the world suggests that all these comprise one nation, whereas people do believe for some reason that there is such thing as an Arab nation, as the Arab nation. The Arab nation was an idea. I don't know if Jamal Abdul Nasser was the first to suggest it, but he was the big pioneer or the big champion of this idea, and it failed. He never succeeded to unite all the Arabs in the world into one nationhood. And this is important because if the conflict, so before I go into that, let me take a step backward and say similar things about Israel. Israel defines itself as the state, as the nation state of the Jewish people. Now, this is a strange thing because a nation state belongs to a nation, not to a people. But let us say that for the sake of the argument, the idea is that the Jewish people comprise a nation and that the Israeli state belongs to that nation. I think it should be known that the Jews of the world, no matter how much they have in common, and they have a lot in common, no person would deny that, still do not constitute a nation, not in the political sense of the word, sorry. So according to this ethos, the Israeli-Palestinian conflict is between two nations that do not exist. This is anti-politics in the most refined form that I can imagine. I want to say a few words. How all this goes back to Popper and Agassi, because it does. And I owe them, I owe Agassi especially, but Popper too, more or less everything that I know about politics. Popper, I think, was the first to suggest that when we are asking questions about statehood, we need to ask not about our far-reaching aspirations, but about minimal requirements. And the question, who is the right leader, who is the appropriate or the, I forget which terminology is used there, maybe somebody can help me. Who is the good leader, which is the traditional question in political science, is the wrong question. Because obviously the good leader is the wise person, the altruistic person, the moral person, etc., etc., etc. Of course. But we don't have such a person. We have all our leaders are human and they are less than demigods. And the question should be, how can we correct the mistakes of leaders? Be they good leaders or bad leaders, how can we correct their mistakes? That is, I think, or maybe the central point in Karl Popper's Open Society. And Joseph Agassi added another question, and that is the question, who is the body politique of the people that the state must be defined as belonging to? And according to Agassi, this question too is a question of minimal requirements, because it is or it should be a minimal requirement of a state to acknowledge the nation of its own citizens. Let me repeat this, because this is a central idea here. A minimal requirement from the state, according to Joseph Agassi, is to acknowledge the body politique of the people that comprise its citizenry. And this is what we call civic nationalism or civic nationhood, the civic nation. And it was invented, incidentally, by the fathers of the French Revolution and the American Revolution. And I think you all will agree with me that this is an amazing observation, that the American Revolution and the French Revolution happened in such a proximity of time, so close to one another. And I once asked Joseph Agassi about this, and he said, these are not two revolutions, it is one revolution. And I find this a fascinating idea, but back to topic with your permission. You are all too quiet, I'm complaining here. So, Themba, I see that you are smiling. It gives me strength to continue. Back to the topic. If it is true that there is a minimal, or there should be a minimal requirement from politics or from the state, it's the same thing, then it can be also agreed that the rejection of these minimal requirements amounts to anti-politics. I have my political views and you have your political views, and I can reject your political views and you can reject mine, and it's okay, there's nothing wrong about that. And I can have my political aspirations, what I want my state to achieve at the end of the day, and you think that you can think that my aspirations are misguided, and you suggest your aspirations, and I can think that your aspirations are misguided, and we will debate all this, and everything is as it should be. This is perfectly okay. But if there is such a thing as a minimal requirement from politics, without which any reasonable or minimally reasonable and responsible politics is impossible, is ruled out, then we need to agree to accept these minimal requirements. And if we don't, then we are anti-politicians. This is anti-politics. And in both Israeli ethos and the Palestinian ethos, both about Israel and about Palestinian, they all agree on the rejection of this minimal requirement that a political body, say the state or national movement, needs to recognize the body politic of the people to which it pertains or to which it addresses. Without this, there is no possibility of responsible politics. It's as simple as that. I don't know, maybe, no, let me rephrase what I wanted to say. As far as I know, maybe somebody here will enlighten me. There are only three philosophers, political philosophies, that call for the rejection of these minimal requirements that I'm talking about. You remember there are two minimal requirements, one by Popper and one by Agassi. Let me repeat them because this is so important. Minimal requirement number one, according to Popper, is that we have a mechanism, some kind of mechanism for error correction. Without this, responsible politics is out of the question. Says Agassi, there's another requirement that the state would acknowledge the body politic of its citizens. And maybe I can add something of my own here. I think that it would be also a minimal requirement to apply what Popper said to what Agassi said. In other words, that we be open to correction in the area of this question. Who are the people that the state belongs to? Who belongs to the body politic that the state is committed to? And we should have a mechanism to enable us to correct errors in that respect, in respect of that very question. I am very proud of myself here, so I beg your forgiveness for being smug if I am. Charles, you want to say something? You don't even need to raise your hand. Speak up. but you need to unmute yourself.
Yeah, since you're eager to get responses from people, I thought I'd just chime in. And
Nice of you.
yeah, I'm not sure. When I look at conflict, and you understand the Israeli-Palestinian thing far better than I do, but I just think in human beings, watching what's happening around the world these days and how depressing it is in the U.S., in Hungary, in Israel,
in Russia, in the Ukraine.
You could go on and on. You
And
know,
on and on.
in
Turkey,
Germany, yeah, in this kind of reversion back to, you know, I don't know, autocracy or whatever you want to call it.
Back to we don't know what. That's God's truth. Go on.
Well, see what I
use the F word.
What I think is that there's a very deep need in human beings to identify with tribes, and it may be. I wish that Dennis Noble or Ray Noble. I don't know if you know them, but Ray was in the conference earlier, and but because they know they're, I guess they're not specifically geneticists, but they know a lot about the genome, and I think it's something that's in our genome or in our epigenome, develops with it in us very early, to want to have a group, kind of the smaller the better, to identify with and to find an enemy to hate.
Absolutely.
Put it very simply, and I think that's why I love Popper so much. Is he emphasizes, not that I understand everything he said, but just how delicate, you know, we've somehow in the past 200 years, we've come up with this liberal society, which provides freedom to a greater or lesser extent, and rule of law, and all these things, and everybody takes it for granted. And now we're losing it because I think we're devolving back to our who we are as human beings, and you really have to fight to keep society the way it had been, you know, or moving forward.
First of all, I agree with every word that you said. Maybe it needs to be added that the idea of civic nationalism does not threaten tribal affiliation, does not clash with tribal affiliation, but it does infringe upon it to some degree. And it is no coincidence that people who are strongly in the speech, I don't know who else noticed it, King sometimes speaks as a Negro speaking on behalf of Negroes and to Negroes. And at other times he speaks as an American speaking on behalf of the American nation to the Americans. And at other times still he speaks as a human being who is speaking on behalf of humanity and to human beings. And what struck me is that he makes these transitions without stating it, without saying a word. He doesn't say, I'm now making a transition. And then I thought about it and I came to an insight, I think, that these transitions are his core message. That it means nothing to be a Negro and to speak to the Negroes and on their behalf if you do not do it as part of the American nationhood, and to see the Negroes of America as Americans first, and that this is in line completely with the American ethos as it was put forth by the founding fathers. And this goes on. It means nothing to be an American if you are not an American as part of being a human being. And when I had these thoughts about this speech, I admit I became so worked up about it that I had to go to take a walk outside the room to chill myself up, because this is a big thing. Somebody wants to say something, I think. Yeah, please, Temba, you don't need to raise your hand.
Okay, my thoughts may not be right.
But you can, I can hardly hear you. I don't know what you can do about it.
Is it better?
Much better, thank you.
I wanted to raise something. I think in times of war, we tend to think of war.
No, I'm sorry. Am I the only one experiencing trouble hearing?
Let
could
me
be
speak
louder.
up 5 minutes. Let me put on my headphones.
Yeah.
Oh, you can help him, Elise?
He said he was just going to put on some headphones, so the headphones.
Oh, headphones with a microphone, I suppose. Let's see.
Okay, so you might have to go at the bottom left where the mute button is. There's an arrow, and you can select a microphone from that arrow. So you might need to select that headset. Does it have a microphone in it?
Select a speaker.
Or select a microphone.
Or select a microphone. Well, until and Temba, until you resolve this, we will continue. Okay? Or you want to say? No.
Now we can't hear you at all. So.
Yeah. Let me repeat what Elise said. If you put the microphone, if you put the headphones with the microphone, if you click it into the computer, you need to press a little arrow on the side of the microphone image at the left lower corner of your screen.
Mm-hmm.
I'm on that
small
there.
arrow,
Try
and you
now.
get.
Okay. I think I know.
No, go.
Oh, we had you for a second.
Give me a minute.
Okay.
Give me
No, it's not working.
You said he said give me a moment, I think so. Let's see if
Okay.
But we can come back to him.
Okay. Back to intractable conflicts and to anti-politics. My thesis, to repeat, is two parts. First, that anti-politics consists in the rejection of minimal requirements of responsible politics. By the way, Joseph Agassi never used this expression responsible politics, because for him, the very business of politics is a responsible business. If you are into politics, you are responsible. And if you are irresponsible politician, you are not a politician. And the two words are like synonyms in his usage. And when he was asked what, in his opinion, was the main problem with Israeli politics, he said the main problem, there are two main problems. One is that there's no such thing. There's no politics in Israel. And two is that disastrously, people in Israel believe that there is politics in Israel. Everybody in Israel thinks that there is such a thing as politics in Israel. And he, Joseph Agassi, denied it. Temba, give it a try.
I think the definition of politics.
I'll be right back.
Hello?
I hear you, and it is broken, so broken that I don't know what to say.
I think, let me just try to speak a bit louder. I'm not sure if it's let me try something.
Forget about the headphones, maybe, yeah.
Yes, I think I should throw them out. Hello?
Yeah?
I tried switching this off. It's off now. What I wanted to say, the issue of politics, I think in many ways, politics has lost its meaning to the extent that what we call politics is nothing but modern mafia, you can call it. A lot of what we call business, a lot of business people have taken over politics, I think, for capitalism. And perhaps the state has business, whilst it needs power from individuals in the state to vote them into power.
Unfortunately, we're only getting maybe every second word. So do you want to type it in chat and then
I think that would be the best.
Maybe.
That would be the best.
Yeah,
Type
type it in chat
and
and then I can read it out for you.
please
I'll
do.
try.
It's a good
Yeah.
idea. Thank you, Elise.
Because we do want to hear from you.
Yeah. Let me go back to the Israeli and the Palestinian example. You know that Israel right now is in conflict not only with Palestinians, but in Lebanon, with a terrorist organization in Lebanon. And Joseph Agassi once made this suggestion, and I made the same suggestion to several Israeli politicians, that Israel should declare that Israel invites Lebanon to make a peace pact with Israel and then to declare war against the Hezbollah together. And that in the same declaration, Israel will also stipulate that if Lebanon should refuse, then Israel will declare war on Lebanon and the Hezbollah. Now, this proposition clearly reflects the acknowledgement of Lebanese sovereignty. And people that I made this suggestion to said that it will not work because Lebanon does not recognize its own sovereignty, which of course is true. That is the case. Lebanon allows for a private army to operate in Lebanon, and not only operate, but also to send its representatives to the parliament and to the government. And this has come to such proportions that this private army, yes, the Hezbollah, is stronger by all estimations, is today stronger than the Lebanese army itself. So this means that Lebanon does not recognize the sovereignty of Lebanon. And it is also a historical fact that Lebanon does not recognize the Lebanese nation, just like Israel does not recognize the Israeli nation. It is a regional disease, I would say. And at any rate, politicians in Israel take the fact that Lebanon does not recognize its own sovereignty as excuse for Israel not recognizing Lebanese sovereignty, which is madness. It is like the old joke, if you beat up my Jew, I'll beat up your Jew. Yes, because they are irresponsible, it is a good idea for us to be irresponsible as well. Maybe with your permission, I'll give another example, which I think might be the most painful example. Ever since 1948 and the Nakba, which Nakba is the Palestinian disaster. It doesn't translate as Holocaust, but it is not far from that. The Palestinian misfortune in 1948, when about 250,000 people became refugees. The Israeli policy was then that the refugee problem is not our problem. And this has been Israeli policy from then until now, even after October 7th, 2023, when we paid the highest price we ever imagined, higher than we ever imagined, for the fact that the refugee problem was never responsibly dealt with by anyone, including not ourselves. And we still hang on to the idea that this problem is not our problem. I ask my friends, in what world is this problem not our problem? In what universe? We talked about the open universe. It needs to be a very, very open universe. There need to be several universes in order for there to be a universe in which the Palestinian refugee problem is not ours. If it is not ours, whose is it? Of course, it is a Palestinian problem. It is the problem of the Palestinians and of the Israelis. There need not be a division of labor here. It is their problem and it is our problem all at once. I think nobody will say that there is a contradiction here in what I just said. And I cannot even begin to imagine why would people say that it is not our problem. But there is an answer to it. The answer is anti-politics. People do not recognize politics as a realm that needs responsible and rational dealing with. Earlier, I said that there are three political philosophies or three philosophies that call for anti-politics, that reject the basic or the fundamental political requirements. And these three are realpolitik, fundamentalism, and fascism. And these three philosophies are so different from one another that it is amazing how well they go together. People who express one often express the other and often express the third. And this makes you think that maybe, just maybe, the differences between them are not that important. What is important is that they all are anti-political. With your permission, I would like to go into the theoretical side of it. Forget for a minute about the Israeli-Palestinian conflict, and we'll go back to it a little bit later. We have so much time on our hands, so we are under no pressure. Is that?
Want to answer Vaden's question first before?
Come on. Anybody who has anything? Yes, please.
Yeah.
Hi, yeah, thanks. I didn't want to interrupt your train of thought. You mentioned something about 10 minutes ago that I just wanted to return to because I found it very interesting, which was Agassi's comment that Israel doesn't have politics.
There's no politics in Israel. Yes, true.
Yeah, so I guess I'm having a difficult time comprehending what he means by that. And I'm contrasting it to something I heard Martin Amos once say about Israel, which is that it's a land without small talk, by which he meant that if you were to visit, the conversations you'll have will quickly turn political. And I kind of took from that his view is arguably that there's maybe too much politics in Israel.
There's nothing
and so I just love,
according to this view, there's nothing but politics in Israel. And I accept both these claims, and this seems contradictory, but let me tell you why I think it is not.
Please, that would be great. I'd love to hear that.
There's nothing but politics in Israel means, that political issues are so, I'm looking for a word, maybe we are so immersed in our political issues, and the political issues touch so strongly and so deeply on every aspect of our lives that nothing that you do or say is innocent of political charge. Everything has political charge. The way you look at me, the way the accent in your voice is political. Your haircut is political. I'm not joking and I'm not exaggerating. So that is one thing. In that sense, in Israel, everything is political. I completely agree. But there are no politics means that there's no people who, there's no political person, there's nobody in Israeli politics who addresses the issues, of the political issues. And there's nobody that addresses the political issues because there's nobody that acknowledges the political issues. Just to give you an example that you will not believe what I'm about to tell you. The most burning political issue in Israel, I think everybody here will agree, is how to end the Israeli-Palestinian conflict. How to bring the Israeli-Palestinian conflict to an end. Now, I don't know if you will believe me. In Israel, nobody asks this question. I find it impossible to believe myself when I say it. And people say to me, you are talking nonsense. Everybody asks this question. And I say, come on, let me hear somebody. Tell me of a person that asks this question. So they tell me, they don't ask it explicitly, but it is constantly in the air. And I say, I know it's constantly in the air. I'm looking for somebody who asks it explicitly, because politics takes problems that are in the air and makes them agenda. And agenda means explicitly. There's no way around that. So thank you deeply for that question.
Is it?
Yeah.
Is it the case that the reason why it's not brought up more often is that it's such a divisive issue? And there are probably people who are fairly secular, and I know there are in Israel, but then there are extreme groups that tend to dominate the coalition. Is that right?
I don't know the answer to that question, but I can tell you that the result of not asking this question is that the divisions become ever deeper, ever more bitter, and ever more threatening to our very existence. And I suggest, maybe I'm wrong, but this is my view at any rate, that the only way to avoid catastrophe is to ask these questions. And yeah.
Hello.
Temba, now we hear you. Whoa, what a sound to sore ears. Go on.
Do you know an author, a former physician called Gabor Mate?
No, please tell me about him.
He recently wrote a book called The Myth of Normal.
The Myth of Normal.
Yes. In the book, he's got a chapter that he talks about leaders who are addicted to power.
Go on.
Now, I've been following his work and the work of Dr. Bessel van der Kolk.
Okay.
And when I look at the news and see what's happening in Israel and Palestine, what concerns me the most is the children that are witnessing the war and experiencing the violence, such that when they grow up, are they likely to seek peace, or are they likely to seek vengeance for the family members that they would have lost through the war? And the level of trauma and the helplessness and the suffering that they're experiencing is unfortunately turning them into people who will seek war than peace.
This is
because
if
you look at the formative years of a person's life, when you grow up suffering, unsupported by anybody, or experiencing events like what is happening now in Israel and Palestine, for the young children there, for the 2-year-old, for the 5-year-old, they are not learning love and peace. They are learning that in life we fight for everything.
I do not need convincing in that. This is the reality of this region, absolutely. If I may, even now in the war, specifically in the war that is being waged right now, which is properly speaking, technically speaking, it's not really a war, because a war is between two armies, and this is not two armies. This is an army and a terrorist organization or some kind of organization. Even now, this war is completely hopeless on both sides. This is what I'm trying to say. With your permission, I want to explain why it is so hopeless on the Israeli side. In order for a war, any war, to present any kind of hope, it needs to be to have a political goal or purpose. And the only political goal or purpose of a war is to subdue your rival and to get them to surrender. Yes. In order that after that you can force them to participate in peace talks so that you can make peace. What I just said, I think, is complete common sense, right? You don't have to be a professor, a university professor, to agree with what I just said. In Israel, no one says this. In Israel, when people talk about the purpose of the war, they say things like to crush the Hamas. Now, don't get me wrong, I'm not against crushing the Hamas or to annihilate the Hamas. I'm not against annihilating the Hamas. I would love it if I could wake up tomorrow morning and our world will be with no Hamas in it. I would be happy like anybody else. But there is one problem. Nobody knows what crushing the Hamas constitutes, what it consists in. What do we mean when we say that? So by putting the crushing the Hamas as the purpose of the war leaves the question completely open for what is the purpose of the war operatively. What do we operatively aim at achieving? This question is left completely unanswered. And it is a burning question. I don't have to explain this to anyone. And burning questions are questions that by definition cannot go unanswered. They must be answered. If you don't answer them openly, you answer them surreptitiously. And this means that the present leadership of Israel gets to decide if they get a complete carte blanche when to declare the war as over. Of course, they want to win the war. Everybody wants to win a war, but what will they consider winning? At what stage will they consider? The question of what should be considered winning a war is such an elusive question, and this can be shown in that many times when a war ends, both sides, each side considers itself triumphant. They say we won the war, and the other side says we won the war. And this just comes to show that nobody really knows what it means to win a war, whereas to subdue the enemy is a practical concept and a formal, official concept that can be determined. You know, when your enemy raises a white flag, then there's no question about it. But
I think,
yeah.
Can we refer to a case of America where after the 2001 attacks, they seeked and found Osama bin Laden after many years and killed him? Can we claim that they have now destroyed terrorism, or they've just killed one man after 11 years of fighting?
I think this is a rhetorical question. I think everybody knows that the answer is no, right?
So the resources that they've spent, can they be justified by killing one man? I don't think so. So even now,
even if they killed even if they would have killed 10,000 Taliban leaders, it would have made, I don't know if it would have made the world a better place, because people say, in Israel too, and all over the world, people say that we need not only to fight terrorists, we have to take care of the terrorist infrastructure, right? And what is the terrorist physical infrastructure? Everybody knows. Israeli forces are fighting against physical infrastructures in Gaza Strip as we speak. But there are also, of course, there is a social infrastructure. And it is a strange thing that when people talk about the social infrastructure of terror, what are the root causes of terror? All over the world, they say the root reasons for terror, or for, let's me be more specific, for Palestinian terror is a combination of fundamental ideas or beliefs, Iranian money, and bitter despair combined. And in Israel, when people say what are the root causes of terror, they say fundamentalism and Iranian money. Do you see what I'm saying?
Yes, yes, yes.
They leave despair out of the
so would you agree then? Would you agree then with me when I say that the very war of destroying Hamas is creating young militants who in future will seek revenge against Israel?
I don't see how anybody can doubt that.
I think the problem right now is we look at the current war and how to stop it and forget that there's going to be future wars that we have a better chance of stopping. The war that has started now is going to be much harder to fix. But the way towards peace, like in my country, there was apartheid in the past. A lot of people had experienced a lot of trauma. And part of me trying to find out why are we so violent towards each other, I did a bit of history on South Africa and its politics. And I realized that the father of apartheid, or the architect of apartheid, qualified with applied psychology in 1928. So when you have a psychologist forming a movement of apartheid, he is not doing it as just another politician. He knows how the mind works. So he created, to a great extent, what we call the African mind of today over a period of more than 30 years with a lot of trauma.
What was his name, please?
Hendrik Verwoerd.
Again?
Hendrik Verwoerd.
Hendrik Verwoerd.
It's an Afrikaans name, yes. So the South African situation was created by someone who had a PhD in applied psychology. He knew how the mind worked.
Yes, I understand completely. In my opinion, the big heroes, well, come on, it's not my opinion. It is an international view, that the big heroes in this story, of course, are Nelson Mandela and Desmond Tutu.
Yes.
And I want to say one thing about them. I think that you will agree that the ingenious invention of the committees for peace and for truth and reconciliation is that the word justice was deliberately left out of this title. I think that they knew that if they would make it the committees for truth, justice, and reconciliation, then this would start a hell all of its own. And And not that I think that Desmond Tutu or Nelson Mandela were opposed to justice, but they said, let justice wait. Let us put it aside for the moment so that we can have hope. I think you agree.
That Desmond Tutu, his bigger interest was in reducing the traumatic suffering of the Black South Africans. One of the things that reduces suffering is understanding what happened to your loved ones who never came home. So I think the TRC was meant to allow wrongdoers to share stories of how they killed people in the interest of their government. And coming back to the issue of Gabor Mate, let's look at this child who grows up in a very difficult environment. By the way, I've got an old friend who was born in the 1940s. As part of the apartheid government laws, his father worked far from home, and he was only allowed to come home once every 6 years for 6 months. So part of the apartheid government's way of destroying how Black people structured their lives was to interrupt the parenting environment. So once you disturb the parenting environment of a child, you are setting him up for failure and for all sorts of evil when he grows up. So this thing called trauma or extreme suffering that renders people helpless is a precursor to war. And how do we then...
Please repeat this last sentence.
Suffering, extreme suffering that renders people helpless, especially when they're still very young, is a precursor to war. And if we want to stop war, we cannot necessarily stop the war of today. It can only be stopped by those who started it, most probably. Where we still have a chance is in looking at the young people and seeing how they are suffering and try and discharge the negative emotions that they carry from their suffering so that they don't grow up hoping to create war to avenge themselves or thinking of it as a way of life.
Yeah, but by the way, this is an interesting observation that, of course, you know that the hatred between the German and the French nations was as deep and as sweeping as any hatred between two nations can be. And it went back, I think, like 150 years back or 200 years back. And still, at the end of World War II, when Germany was completely subjugated, the governments signed peace agreements or peace accords in complete defiance of the atmosphere in their countries, which the atmosphere was not, nobody wanted. The two nations were so revengeful that it was like unlikely that they could ever live in peace, and yet the peace accords were signed, and 80 years have passed since then, and there has been no war. This is an amazing observation in my view, and it was not necessarily, it was not, there was no assurance that it is going to work, but it did. And I have no idea how things will end up here, because as things are today, there is not a single Israeli or Palestinian leader that is willing to do the responsible thing.
So Sadia has had her hand up for a little while. So.
Who? Oh, Sadia, sorry, Sadia, sure, you don't need to raise your hand, just speak.
All right, thank you, thanks. No, I was actually thinking about this whole situation. I'm originally from Pakistan, and having seen this in, now I live in US, but this whole thing of Taliban creation, and I mean, I was still young at the time when the when this whole Islamic, fundamentalist ideology started to become an issue. And it's pretty much well known in Pakistan, at least, how that happened. There was kind of all those ideas were, it was all about, creating an enemy against Russia that seemed to have been a quick fix for US to find an enemy somewhere else who could do our dirty work and fight. But I guess what I really wanted to say was that it seems like, this whole thing about dealing with terrorism and extremism is not that different from like sometimes how we approach medicine. It's like, when the cancer has spread, when suddenly now, you're like the body's or something is happening or something bad has happened, we try to treat it. And then, and then you give all these medications and they have side effects and stuff. But why don't we have preventative?
Why don't we amputate?
Or no, I would say, why don't we have preventative medication? Why don't we, why don't we do the things to prevent the problem in the first place? And it seems like a lot of times that happens when we try to fix things. And again, we kind of had this mentality as if we are some isolated system, but we aren't. Again, going back to the open closed systems type thing. And then, the monsters we create eventually in some shape or form come back, and also bite us.
Yeah.
So I don't know why and I guess it's not that interesting of a talk in politics for people to start thinking, and public typically does not participate in long-term solutions. This always comes down to right away what needs to be done, whatever's the quick fix. And it seems like we resorted quite a bit to quick fixes where we created bigger problems in the future, like terrorism.
But
one of the problems is that there are no counterfactuals. You can see where it went wrong, and you can see where there's ethnic conflict or national conflict, or like in Pakistan, next to India. I mean, the terrible problems they're having in India with fundamental Hinduism, but you don't know how many episodes like that were prevented by something that happened over the course of what policy. There's no way to know what policies work to avoid that kind of thing, I guess I'm saying.
Yeah, but you can always try to set a goal. For example, if I may relate, Sadia, to your native country, I consider Malala Yousafzai a politician. I don't know if you would agree to that. I consider her a politician, not in effect, also in effect, but also in thought, in principle. When she was 10 years old, she was a politician. And I cannot even begin to tell you how I admire her. But again, I'm in a very big crowd. I believe she has millions of admirers all over the world. But here I'm giving her an example, maybe not of one thing, but two things. One is political orientation. She cared about the situation of women, of girls and women in Pakistan and all over the country. And she wanted to make things better. This is political orientation. This is one thing. But there's also another thing. She had the courage to speak up.